Hello and welcome. My name is Syed and I have created this introductory course in R programming. You might wonder what is R and why you should learn R programming. Well, R is a popular programming language adopted for data science and statistics. The R programming language is used by professionals and data experts around the world for mapping marketing trends and modeling financial data and so on. And the best thing is R programming language is free. R is an open source statistical programming language supported by a vibrant community. R is also called the language for statistical computing. R runs on almost any computing platform and operating system. R provides a rich collection of statistical techniques or functions and has sophisticated graphical and visualization capabilities for plots and graphs. This language also provides complex and sophisticated visualization of high-dimensional data. Another very important feature of R is that it is highly extensible. R language is not strictly in the sense only for statistics, but also for advanced mathematical modeling and machine learning. This introduction to R course is the best way to start learning R programming and getting handy with its features. In this course, we will cover the R's basics and programming fundamentals. Eventually, you will learn how to use R's data structures such as vectors, matrices, lists, and data frames. Each of these sections includes screencast of hands-on implementation and is also accompanied by short quizzes. Finally, we will look at how to import data from various sources and how to handle large data. And on top of that, in this course, we will move deeper into the graphical capabilities of R and learn how to create visualization which will help in analysis. At the end, we will perform basic statistical analysis on specifically designed stock price datasets to get the real feel of our statistical computing capabilities. In this video, we will show how to install R on your computer. So let's begin the installation process by going to cran.r-project.org. This website will look similar to this. It may be updated from time to time as far as the look and feel is concerned. But in general, we will have the download link for various installers, for Linux, for Mac OS, and Windows platforms. And if you click on one of these, you will be taken to the actual download links for various installers. So if you are on Windows, go ahead and click the link Download R for Windows. You will be taken to R for Windows page. Go ahead and click Install R for the first time. And now click the link Download R 3.6.1 for Windows. By the time you view this video, it's most likely that the latest version has been released. So keep in mind any latest version will be fine for R programming. Once you have downloaded the R installer for Windows, just open it and follow along with the step-by-step instructions. Select the language, most probably it will be English, and click OK. Click Next. Graphical installers are pretty straightforward. You just select the defaults and click Next. You can select the Create Desktop shortcut. Before you proceed with the installation, it is highly recommended to associate R with R data files. So just go ahead, select Associate R with .r data files and click Next. So now that we have R installed on our computer, just click Finish. To check the installation of R, just click Start on Windows. You should have R folder in Programs. Expand it and click on R i386 if your system is a 32-bit operating system, or click on RX64 if your operating system is 64-bit. Generally, nowadays, if it is Windows 7 or Windows 10, it's 64-bit. So just go ahead, and in this case, I will click RX64. Which will open R console, which is the interface to run R code. And it should look something like this. This interface will allow you to execute R commands directly within the R console. Next, we are actually going to type some R statement. Go ahead and type print, open and close parenthesis, and in single quotes, type hello R and hit enter. You should be able to see hello as the output. So this is how you can run R code. Now you have successfully installed R, and in your R console, you have written your first R code and executed the print statement. The R console is the R's simple command line, allowing you to type R statements directly and execute them. We won't really be using the R console command line because it executes one statement at a time, and eventually we will be writing programs having more than one statement of R code. So now let us explore how to install RStudio, which is R's integrated development environment. In this video, we will show you how to install RStudio on your computer. So let us begin the installation process by going to rstudio.com. The website will look similar to this. It may be updated from time to time as far as the look and feel is concerned. But in general, it will have the download link. By clicking this link, you will be taken to download RStudio page. Here you can find download button for open source license and for commercial license. The open source license is free. And if you click on one of these, you will be taken to the actual download links for installers of various platforms. So if you are on Windows, go ahead and click the link under Installer for Windows. If you are on macOS, click here and download this installer. Once you have downloaded the RStudio installer for Windows, just open it and follow along with the step-by-step instructions. Here you can change the destination folder, but I prefer not to change the destination folder and proceed by clicking Next. Just go ahead and click Install. Graphical installers are pretty straightforward. You just have to click Next. So now that you have RStudio installed on your computer, click Finish. To open RStudio, click Start on Windows. You should have RStudio folder. Expand it and click on RStudio, which is the integrated development environment to run R code. When the RStudio IDE starts, it should look something like this when using for the first time. So now that you are ready with the execution environment, let us get started by looking around the RStudio interface. RStudio is an integrated development environment. It is a GUI where you can write the code, look at the result, and also have a look at the objects generated during execution. This is how the interface looks when we start the RStudio. We will create a new R script by clicking on the green button on top left corner of the interface. We will click R script. You can also use Ctrl plus Shift plus N to create a new blank R script. Here you can find an empty file created where you can write your R program. To the left bottom, we have the console window where we can directly type the commands and also look at the results. To the top right, we have Environment and History window. You can find several tabs. The first tab is the Environment tab, where we can look at the objects generated during the course of execution, and the History tab, which displays the commands used. To the bottom right, we can find the window which contains tabs such as Files, which displays the directories and files available in the default workspace of R, the Plots tab, which displays the plots that are generated during the course of execution of R script, Packages tab, which displays the packages that are installed in RStudio. We can also install new packages or update already installed packages. The Help tab is used to access the documentation, where we can browse and refer to almost every aspect of our programming language. And finally, we have the Viewer tab, which is used to look at the web content generated using R. Before we proceed further, we need to specify the working directory. We can use the command setwd and specify the directory name, or we can browse for directories by clicking the three dots and set the working directory using Graphical User Interface. In this case, I will be creating the directory LearnR in my drive and will click Open. You can find that the location of the working directory is displayed. Here in the working directory, we do not have files and directories as of now. Let us now click More button and click Set as Working Directory. You can find that the R command setwd with the directory name is executed in R console. Though this new file doesn't have any R statements, but let's save this file by clicking the Save button on the interface menu. Let us give the name as test.r. The uppercase R is the default file extension for R scripts. And let us click Save. You can find that the file test.r is saved in the current working directory. We can clear the console by clicking this broom button on the top right corner of the console window. You can also clear the environment workspace by clicking the broom button on the menu of the environment window and clicking Yes. We can also save the environment workspace by clicking the Save button on the menu of the environment window and provide a name. In this case, let us say Test and click Save. You can find that the test.r data file is saved in the current working directory. So now that we have seen the RStudio interface, we are now ready to write our first R program. So let us get started by writing the R program in the next video. In this section, you will learn the basics and we will start by writing our first R program. To write R programs, we will be using RStudio. Let us open RStudio. To open RStudio, click on the search box right next to the Start button on Windows and type RStudio. In the results window, you will find RStudio icon. Click on this icon to proceed. You will find an interface for RStudio displayed. Before we write our programs, we need to set the working directory. So let us browse the directory by clicking on the three dots button on the top right corner of the Files window. In this case, I have a directory Learning R in my D drive. You may create or use a different directory to write your R programs. Select it and click Open. You will find all the directories and files, if any, from the selected directory displayed in the Files window. Now click the More button on the Files window menu and click Set as Working Directory. You can select an existing file to write R code, or in the RStudio on top left corner you will find green plus icon. Clicking on this icon will open a drop-down menu. Now click on R script. You can also use Ctrl-Shift-N to open a new R script. A blank file will be created. Let us try our first program in R. Perhaps the simplest program you can write is a print statement. We are actually going to type some R code. Go ahead and type print, open and close parentheses, and in quotes we will type hello R program. To run R script, you should have the cursor on the statement and click the run icon. You can also use Ctrl-Enter as shortcut. The result will be displayed beneath the console window. You should be able to have the output as hello R program in the console window. So this is how you can run R scripts. When you run the print statement, R will simply display the value within the parenthesis. The statement or expression is an instruction the computer will run or execute. The value in the parenthesis is called an argument. The print statement is executed in our environment and the result is displayed in the console window. The one in square brackets shown in the console window indicates that the output is a vector, and the index of the vector is printed in square brackets. In this case, it is 1. Before we move further with the basics of R programming, let us first save our work, that is, the R statements or program. To do this, click on Save icon. Save file window pops up. Enter the file name. In this case, we will enter as test and provide the extension as .R. The uppercase R is the default file extension for R scripts. Let us click the Save button. You can find in the Files window that the file will be saved with the name as test.r. Though you can use R console, but using RStudio is more convenient way of writing complex R programs and executing them. We will follow the RStudio execution paradigm in the video lectures throughout this course. In this video, you will learn how to perform basic mathematical operations in R. Let us start by writing our script to add two numbers, that is x plus y. Let us assign value 18 to x. To do this, we will use x less than character followed by hyphen and the value 18. The symbol less than followed by hyphen is an assignment operator. The assignment operator consists of two characters, less than and hyphen, occurring strictly side by side, and it points to the object receiving the value. Here x is known as a variable and 18 is the value assigned to variable x. Actually, everything in R is an object. So here x is a variable as well as we can call it as an object. In the same way, we will declare y and assign the value 4 using the assignment operator. Let us now apply the addition operation using the plus symbol on x and y. So we will have x plus y where plus is the addition operator. We will store the result or assign the result to new variable z using the assignment operator. We will now display the result stored in z. We can either use a print statement, passing z as the argument, or simply we can have variable name, that is z in this case. Let us execute this R script by placing the cursor on the first line and clicking the run icon. The first line is executed and the variable x is assigned value 18. In the environment window, we can find that x is storing value 18. In the same way, the second line is executed and the variable y is assigned value 4. We can find that y is storing value 4 in the environment window. The third statement computes the sum x plus y and the result is assigned to variable z, which stores the result 22. The next statement will display the result in the console window, that is the result 22, which is the value stored in variable z. We will execute the next statement, which also will print the value stored in variable z. Do observe that we cannot just click the run icon to execute the program. The cursor should be on the line that needs to be executed. Once the statement is executed, the cursor automatically moves to the next line of the code. The advantage of using run is that it makes debugging and troubleshooting easier, since each statement is executed at a time. Instead of assigning values to the variables and then computing the expression, we can directly perform 18 plus 4. When we place the cursor on this line and then execute, we get the same result. The other mathematical operators that can be used are as follows. We can use subtraction, that is 18 minus 4 will give us the result as 14. In the same way, we can have 18 multiplied by 4. We have the result as 72. We can also perform division operation, that is 10 divided by 2, which gives the result as 5. We can also have floating point numbers in the expressions. For example, 4.5 divided by 2 will give the result as 2.25. In our programming language, we also have exponential operator. That is, we can have 2 exponential 3. The exponential operator has 2 consecutive asterisks. The result of 2 exponential 3 is 8. We can also use caret symbol as an exponential operator. For example, 2 caret 3 will give the same result as 8. We can also perform exponential on floating point numbers, that is 3.5 exponential 2 will give the result as 12.25. In the same way, suppose if we have to find the square root of a number, for example, in this case, let us find square root of 9. So we will have 9 exponential 0.5. This will give us the result as 3. We can also use the expression 9 exponential operator and then 0.5. This will also give us the same result, that is 3. Let us look at what happens when we use 9 exponential 1 divided by 2. We get the result as 4.5, not 3. This is because the exponential operator has higher precedence than the division operator. So therefore, 9 exponential 1 is computed first, which gives the result as 9, and then divided by 2 will give us the result as 4.5. But suppose if we use 9 exponential operator and then we use brackets, and inside brackets we have 1 divided by 2 will give us the result as 3. This is because parenthesis in the expression has got higher precedence than any other operator. So therefore, since 1 divided by 2 is within parenthesis, we have the result as 0.5, which is applied as exponential to 9, and we get the result as 3. In this video, we have covered arithmetic operators such as addition, subtraction, multiplication, division, exponential. There are other special operators in R which can be used to perform arithmetic operations such as integer division and modulus. The special operators will always use percentage symbol. Let us try to look at how modulus operator works. Let us have a number 14 modulus 4. This gives the result as 2. Modulus operator will return the remainder of the division. So when we divide 14 by 4, we get the remainder as 2. We can also have floating point numbers for modulus operation. For example, 14.75 modulus 4 will give the result as 2.75. Even the second operand of the modulus operator can have floating point number. For example, we can have 10 modulus 3.5, which gives the result as 3. Let us now look at the other special operator, that is an integer division. Let us apply an operation of dividing 8 by 3. So we have 8 divided by 3. The result is 2.66. Now suppose if we apply integer division, that is 8 integer division 3, we get the result as 2. The integer division always returns the integer part of the normal division. For example, when we have 8 divided by 3, we have the result as 2.66. And when we have 8 integer division 3, we get the result as only the integer part, that is 2. Let us now look at what happens when we have negative numbers in integer division. For example, minus 8 integer division 3. We get the result as minus 3. This is because when we apply minus 8 normal division 3, we get the result as minus 2.66. Integer division will always return the floor value. So therefore, the floor of minus 2.66 is minus 3. We will have the same result if we perform 8 integer division minus 3. Therefore, always remember that when integer division is performed, the result will be floor of the normal division, whether the operands are positive or negative. We can also perform arithmetic operations on Boolean values. For example, we can have true plus true. We get the result as 2. In the same way, if we have false plus true, we get the result as 1. This is because true can be coerced to have a value 1 and false can be coerced to have value 0. So therefore, when we apply true plus true, we are in turn performing the operation 1 plus 1, which gives the result as 2. In the same way, when we perform false plus true, we are performing the operation 0 plus 1, which gives the result as 1. Please remember that we cannot apply arithmetic operators on strings. For example, we cannot have in single quotes hello plus R. This will give us an error. In the same way, we cannot have hello plus 5. This will also give us an error. In this video, we will cover variables in R. We can use variables to store values. Variable is a name that is associated with a value. A variable can be assigned different values during a program execution. Hence, it is called a variable. In this case, we assign a value 10 to the variable myVar using the assignment operator. That is, in this case, it is equal to sign. We can then use the value somewhere else in the code by typing the exact name of the variable. We can assign a new value to myVar using the assignment operator. We assign a value 20. The variable now has a value 20 stored in the memory. The old value of the variable is replaced by the new one. We can also assign one variable to another variable. It's a good practice to have useful or meaningful variable names. The variable names in R can be alphanumeric and can have underscore as well as dot. Variable names always have to start with alphabets. Special characters in variable names cannot be used, such as $, percentage, hash, etc. In R, variables have to be assigned values at the time of declaration. Before we move further, we will discuss more about declaration of variables in different programming languages. Programming languages are characterized as statically typed and dynamically typed. In statically typed languages, the type of data has to be explicitly defined, such as in C, C++, and Java. For example, int myVar equal to 10, where myVar is a variable declared by explicitly using int data type, and then the value of 10 is assigned. Whereas in dynamically typed languages, the variable is not defined using type. Instead, the type of data is determined at runtime. For example, myVar equal to 10, where myVar is defined without the type of data. When during execution, the value 10 is assigned. Its type is determined to be of integer. R is a dynamically typed language. Therefore, we will not be declaring variables by its type. In R, everything is treated as an object. Let us consider x equal to 10. In R, x is treated as an object as well as it can be simply called as a variable. Now let us look at few R functions. We have a variable x which is assigned a value 10. We can apply type of function on variable x. The type function returns the type of the object. In this case, it is double. R provides a function known as mode, which returns the mode of the object. In this case, it will be numeric. We can also use storage.mode, which returns the way the object is stored in the memory. In this case, it will be double. We can also use a class function, which returns the class of the object. Let us define a variable known as age. If we execute the statement using the run button, we get an error. This is because we have created an object or a variable age but have not assigned a value. Let us assign a value using the assignment operator. Now when we execute the statement, we do not have any error. We can also use alphanumeric variable names. For example, I can have marks1 and assign the value as 10. I can also use underscore in variables. For example, let us have subject underscore Java and assign the value, let's say 20. But I cannot use special symbols such as, for example, I cannot have $subject and assign the value as 15. This will give us an error. In the same way, a variable cannot start with a number. For example, we cannot have numerical 3 and subject. This will also give us an error. So always remember that variable names can be alphanumeric with the special characters as underscore and dot, but it cannot contain any other special character, as well as the variable names cannot start with a number. Let us now look at various R functions that are available to find the characteristics of a variable. Let us have a variable x and assign a value 10. We will use type of function and pass the argument as x. When we execute these statements, we will get the result as double, which is the type of variable x. We can also use a mode function This will give us the result as numeric, that is the mode of variable x. We can also use storage.mode function, which also will give us the result as double. And finally, we can use class as the function to find the class of variable x, which is numeric. Now if we use a floating point number such as 10.75 and then find the class of x, it will again be numeric. So whether you are using integers or whether you are using floating point numbers, the class of the object or variable will always be numeric. Suppose during execution, x is assigned with a different value, that is, let's say hello, which is a string. We will also have a statement to find the class of x. We will execute from the first line. At this point, the class of x is numeric. And on line 3, we are assigning a string to variable x. And now the class of x is character. Therefore, during execution, the type of variable may change depending upon the value which is assigned. Suppose if we have a boolean values, that is x is assigned a value true, then the class of x will be logical. Variables can also be used in expressions, which is a combination of symbols that evaluates to a value. The expression consists of combination of operators and operands. In this case, we have a and b as two variables, which is assigned the value 10 and 20 respectively. Let us have an expression a plus b. Here a and b are operands and plus is the operator. We can store the result of the expression. In this case, the result of a plus b can be stored in variable res. Res variable now holds the result of the expression a plus b, which is 30. The R language has certain predefined words known as keywords. Keywords are reserved words in R. Keywords are identifiers that have predefined meaning in a programming language. Keywords define the syntax and structure in R language. Therefore, keywords cannot be used as variables or identifiers, such as function name or class names. Here is a list of keywords which have predefined meaning in R. As of now, R has 22 keywords. All keywords in R are case sensitive. Let us pick a keyword, that is break, and try to use the keyword as a variable. For example, I will define break and assign a value 10. When I execute the statement, I will get an error because keywords cannot be used as identifiers. In this video, we will talk about data types in R programming language. There are several basic R data types that are frequently used in R programming language. We will try to understand them better by directly experimenting with the R code. In the R programming language, when the variable is created, it is considered as a vector having only one element, that is vector of length 1. We will defer the discussion of concept of vectors until later tutorials. The most commonly used data type in R programming language is a numeric. The numeric data type is a default computational data type. Let us create a variable x, and using the assignment operator, let us assign the value as 10.25. In this statement, x is declared as a variable of type numeric. In the next statement, let us display the value of x. To find the data type of any variable, we can use the class function. The class function takes in the argument, which is the variable. In this case, it is x. When we execute these statements, you can find that first statement has created a variable x, the second statement has displayed the value stored in the variable x, and the third statement uses the class function which returns the data type of variable x. In this case, you can find that we have the result as numeric. Let us assign an integer value to variable x. That is, in this case, it is 10. When we execute these statements, you can find that the type of variable x is still numeric. We can use a function s.integer and pass the variable x. When we execute the statement, you can find that we get the result as false. This is because even though we have assigned an integer value to variable x, it is still considered as a numeric data type. In order to create an integer variable in R programming language, we need to invoke integer function. For example, we can use as.integer and then pass the value as 10. When we execute these statements, you can find that the class function returns integer as the type of variable x, as well as the is.integer function will return a value true. We can also declare integers by appending an else suffix to the value. When we execute these statements, you can find that even now the variable x is an integer. The integer function can also take floating point values or decimal values. But this floating point value, that is in this case 10.25, will be converted to an integer. And when we execute these statements, you can find that we have the value stored for variable x as 10. And the data type, that is the class of variable x, is integer, as well as isInteger function will return value as true. We can also pass decimal numbers as characters as an argument to the integer function. For example, in this case, let us use 5.75 within single quotes. When we execute these statements, you can find that we have the result as value 5, which is stored in variable x, and the data type of variable x will be integer, as well as isInteger function will return as true. But suppose if we have a non-numeric value, that is in this case John in double quotes, passed as an argument to the integer function, you can find that we have a warning message and the value NA is stored in the variable x. NA in our programming language stands for not available, but still the type of variable x will be integer, as well as the is.integer function will return the value as true. Another data type in our programming language is the complex numbers. We use the character I to refer to complex numbers. For example, we can have a variable x and using the assignment operator, we can have the value as 3 plus 4i. We will print the value of x as well as we will find the type of variable x using the class function. When we execute these statements, you can find that x is storing a value 3 plus 4i and the type returned by the class function of variable x is complex. We can also create complex numbers using only the imaginary value without the real part. For example, in this case, let us use 4i as the value of the complex number. When we execute these statements, you can find that the value stored in variable x is 0 plus 4i, which is a complex number without the real part, and the data type returned by the class function for variable x is complex. R programming language also supports logical types. Let us create a variable x and using the assignment operator, let us assign the value as true. Please note that the logical value true is in capital letters. We will print the value stored in variable x, and in the next statement we will use the class function. When we execute these statements, you can find that the type returned by class function for variable x is logical. For logical true or false values, we can also use capital T and capital F. For example, let us assign a value capital T to variable x. When we execute these statements, you can find that we have the same result. In the same way, we can assign a value capital F to variable x. When we execute these statements, you can find that the variable x is still of logical type. Another important data type in our programming language is character. Let us create a variable x and using the assignment statement, let us assign the value as Jack. The value of Jack is within single quotes. We can also use double quotes to represent strings. In the next statement, we will print the value stored in x, and in the subsequent statement, we will use the function class of x. When we execute these statements, you can find that the value stored in variable x, that is Jack, is displayed in double quotes, and the type returned by the class function for variable x is character. Let us look at what happens if we have a decimal value within single quotes. In this case, we will have a value 3.75 within single quotes. When we execute these statements, you can find that the value stored in variable x is 3.75, but still it is a character which is evident from calling the class function, which returns the type of variable x as character, since the value assigned to variable x is within single quotes. We can also use function as.character to create character variables. For example, in this case, let us use as.character and we will pass the argument as 3.75. When we execute these statements, you can find that the value 3.75 is displayed within double quotes, and the type returned by the class function for variable x is still a character. We can use is.character function and pass the argument as variable x. When we execute the statement, you can find that we have the result as true. So these are some of the data types which are frequently used in R programming language. In this video, we will talk about assignment of values to variables. Values can be assigned to variables using three different ways. We can use the assignment operator, which is the symbol less than followed by hyphen, which occurs strictly side by side and points to the object receiving the value. In most ways, the equal to operator can also be used to assign values. Though equal symbol can be used as assignment operator in R, but equal symbol doesn't work in R console. The third way to assign values to the variables is using an assign function. We can use the assignment operator such as x less than followed by hyphen 10 to assign value 10 to variable x, or we can use x equal to 10, which assigns value 10 to variable x, as well as we can use assign function passing two arguments. The first argument is the variable or the object, and the second argument is the value to be assigned to the variable or the object. In this case, 10 is assigned to variable x. So we can use x less than followed by hyphen 10 to assign value 10 to variable x, or we can use y equal to symbol and have value 20, where 20 will be assigned to variable y, and we can also use assign function, that is assign. The first parameter within quotes will be the variable, that is in this case it is z, and we will assign the value 30, that is we will pass 30 as the second argument. When we execute the first statement, x is assigned value 10. The second statement uses equal to symbol to assign value 20 to variable y. And the third statement uses assign function to assign value 30 to variable z. We can also use assignment operator in opposite direction, that is 50 hyphen greater than symbol, and let us use the variable as w. When we execute the statement, you can find that the value 50 is assigned to variable w. So always remember that the arrow of the assignment operator will always point towards the variable which will store the value. We can also define and assign values to multiple variables in a single R statement. For example, we can have a assignment operator, b assignment operator, c assignment operator, and the value as 8. When we execute the statement, you can find that the variable a, b and c will all be assigned with the value 8. Here the variable a is assigned value 8, the variable b is also assigned a value 8, and variable c is also assigned a value 8. So therefore, in a single statement, we can assign value to multiple variables. We can also use predefined constant to assign values to variables, such as pi, letters, and month.name or month.abv. Let us use x assignment operator pi, and let us print the value stored in variable x. We will execute these statements, and you can find that the value of pi which is stored in x is 3.141. We can also use letters in small case. Let us execute this program. You can now find that the variable x is storing all the alphabets small case. We can also have predefined constant, that is letters in capital case. This statement will store all the alphabets in uppercase. We can also have month dot name, which gives the result as months. In the same way, we can have month dot abb, which gives the result as abbreviation of months. In this video, we will learn about comments in R. It is customary to comment your code, which helps in documentation. You simply put a hash symbol preceding your statement to be commented. For example, hash age equal to 24. That is line 1. When you run the code, R will ignore the statement which is commented. There is no concept of multi-line comments in R. However, for commenting multiple lines, each line must begin with a hash. The easiest way to comment multiple lines is to select the statements and then open the code menu. You will find comment uncomment lines. Click this. All the selected lines will be commented. You can also use shorthand to comment multiple lines by selecting them and pressing Ctrl, Shift and C. So this is how the comments can be added to R statements. In this video, we will talk about relational operators in R. There are 6 relational operators, that is less than equal to, greater than equal to, and not equal to. Let us practically see how these relational operators work. Let us have a variable x and assign the value as 10. We will also have a variable y, which we will assign the value as 20. And we will apply relational operators on variables x and y. Let us have x less than y. We will execute the first statement, which will assign value 10 to variable x. The second statement will assign value 20 to variable y. And in the third statement, we are using relational operator. The application of relational operators will always result in a logical value, that is true or false. So when we execute the statement x less than y, we get the result as true because x, that is 10, is less than y, that is 20. Suppose if we have x less than equal to y, even then we get the result as true. Suppose if we use x greater than y, we get the result as false because 10 is not greater than 20. The same way we can use x greater than equal to y. In this case also we have the result as false. We can also use x equal to y. This will also give the result as false because 10 is not equal to 20. Let us use x not equal to y. In this case we get the result as true because 10 is not equal to 20. The relational operator also works on floating point numbers. For example, we can have the value of x as 10.75 and value of y as, let's say, 20.45. When we execute these statements, we will get the result as a logical value, depending upon the numbers in the variables. We can also apply relational operators on strings. For example, we can have value of x as hello and value of y as, let's say, program. Let us execute these statements. You can find that x less than y, the value is true. Since both the operands are string, the relational operator works according to the dictionary order. That is, x has a value hello, which occurs before the word program in the dictionary. So therefore, x less than y is true. Same way, x less than equal to y is also true. But whereas x greater than y, that is hello is greater than program, is false. So you can apply relational operators on numbers, that is integers or floating point numbers, as well as on strings. Do remember that we cannot use multiple relational operators in sequence. For example, let us have a variable z which we assign the value as, let us say, lines. And we can use x less than y, which gives the result as true. But we cannot use x less than y less than z. This will give us an error. So we cannot use multiple relational operators in sequence, or we cannot have chaining of relational operators, though multiple relational operators can be used along with the logical operators. In this video, we will talk about logical operators in R. There are three logical operators in R: AND, which can be used as a single AND or double AND, OR, which can also be used as a single or double OR, and NOT. The double AND and double OR operators cannot be used for vectorized operations. Let us practically see how the logical operator works. Let us have a variable x and we will assign the value as true. We will also have a variable y which we will assign the value as true. We can use a statement x and y to demonstrate the logical operator. Let us execute these statements. The result of the AND operator will be true if both the operands are true. If any one of the operand is false or both the operands are false, then the result of applying the AND operator will be false. So, if it's true and true, then the result is true. If it is true and false, then the result is false. Or, if it is false and false, the result is again false. So, for AND logical operator, if both the operands are true, then the result is true. Else the result is false. In the same way, let us use the logical OR operator. That is, true or true, the result will be true. True or false, the result will again be true. But false or false, the result will be false. So, for the logical OR operator, if both the operands are false, then the result is false, else the result is true. The NOT operator works as a complement. So if we have true, then the NOT of true will be false and NOT of false will be true. We have seen the working of logical operators on logical values. We can also apply logical operators on integers. That is, we can have 10 and 10, which will give the result as true. But suppose if we have 10 and 0, we will get the result as false. Now this is because in R, 0 is represented as false and any number, including the negative numbers, are represented as true. So in this case, 10 is represented as true and 0 is represented as false. So the result of true and false is false. Now suppose if I have NOT of 10, I'll get the result as false because 10 is represented as true. It's a non-zero positive value, that is true, and NOT of true is false. But suppose if I have NOT of 0, I will get the result as true because 0 is represented as false and NOT of false is true. Suppose if I have minus 3, that is NOT of minus 3, I'll get the result as false because minus 3 is treated as a non-zero number. Though minus 3 is a negative number, but it is a non-zero number, so it is treated as true. And NOT of true is false, so therefore we have the result as false. But remember that logical operators will not work on strings. Logical operators only work on logical values, that is true and false, as well as it works on numbers. So therefore if I use NOT of a string, that is hello, we will get an error. So this is how logical operators can be used in R. In this video, we will talk about how to generate sequence of numbers in R. R provides a colon operator and sequence function which facilitates generating sequence of numbers. For example, we can use colon operator, that is, suppose if we use 1:10 and assign it to variable x, as a result we get the sequence of numbers starting from 1 till 10. We can also generate the sequence in a reverse order. For example, we can use x and assign 10:1. As a result, we get the sequence starting from 10 till 1 in reverse order. We can also perform arithmetic operations on sequences. For example, if we have a sequence from 1:10 and if we multiply that by 2, we get the result as a sequence of numbers starting from 2 till 20. In this expression, first the sequence is generated from 1 to 10 and then each element of the sequence is multiplied by 2. We can also perform other arithmetic operations. For example, suppose if we have a sequence from 1 to 10 and then let us have -1, we get the result as a sequence of numbers starting from 0 till 9. Here what is happening is, first the sequence from 1 to 10 is created and then each element of the sequence is subtracted by 1. So we have the result as a sequence of numbers from 0 to 9. Let us look at another scenario. Suppose if we assign a value 5 to variable x and we can use 1:x to generate sequence of numbers from 1 to value of x. When we execute these statements, we get the result as a sequence of numbers starting from 1 to 5. Now suppose if I have 1:x minus 1. This statement will generate a sequence of numbers starting from 0 to 4. Now here, first, sequence of numbers is created from 1 to 5. That is the value of x. And these sequence of numbers are then subtracted by -1. So therefore we get the result as a sequence of numbers starting from 0 to 4. Now suppose if we have 1: and then x minus 1 in parenthesis, we get the result as a sequence of numbers from 1 to 4. This is because in R, parentheses take highest priority. So therefore, the expression within parentheses is evaluated first, that is x minus 1. In this case, it is 5 minus 1, which is 4. And now the sequence of numbers are generated using 1:4. We can also use a seq function provided by R to generate sequence of numbers. This function has 5 arguments. Some of them are optional. The first 2 arguments specifies the beginning and end of the sequence. For example, we can use a variable x and then assign sequence using the sequence function, that is seq. Let us pass the first argument as 1 and the second argument as 5. The first argument is the beginning of the sequence and the second argument is the end of the sequence. Let us try to use x to print the sequence of numbers. When we execute these statements, we can find that we have the sequence of numbers generated from 1 to 5. This result is same as using 1:5. For the sequence function, if only one argument is specified, then it is the end of the sequence. For example, if we use seq of 5, this will generate sequence of numbers from 1 to 5. Here, since only one argument is provided, it is the end of the sequence. And by default, the sequence starts from 1. So we have the result as sequence of numbers from 1 to 5. We can also use names for the arguments. For example, we can use from, let us say 1, 2, 5. When we execute these statements, we get the same result, that is a sequence generated from 1 to 5. Suppose if we use from 5 to, let's take 2, we get the result in the reverse order, that is a sequence starting from 5 till 2. The third argument of the seq function is the step. So we can use 1, let's say 10, 2. Now here 1 is the start of the sequence, 10 is the end of the sequence, and 2 is the step. When we execute these statements, you can find that we have the result as the sequence of numbers starting from 1 and ending at 9, and every next element is incremented by step 2. The third argument can also be used as a named argument, that is, by equal to 2. When we execute this, we get the same result. The fourth argument of the seq function is the length, which generates a sequence with numbers of elements equal to the length. For example, we will use the sequence function with the first argument as the start of the sequence, the second argument as the end of the sequence, and the third argument we will provide it as the length and assign the value as 4. Let us execute this program, and you can find that we get the sequence of 4 numbers starting from 1 till 10. Let us look at what happens if the length is 5. Let us execute these statements. You can find that we get the sequence of 5 numbers starting from 1 till 10, and the result is the sequence of numbers in floating point, because the range from 1 till 10 have to be divided into 5 numbers. So we have the first element as 1.00, the second element as 3.25, the third element as 5.5, the fourth element as 7.75, and the fifth element is 10.00. Apart from generating sequence of integers, we can also generate sequence of floating point numbers. That is, we can use the beginning of the sequence as 1.0, the end of the sequence, let us say 2.0, and then we can use a step of 0.2. Let us execute these statements. You can find that we have a sequence starting from 1.0, ending at 2.0, and at each step the element is added by 0.2. Let us look at what happens when we have the step argument as 0. For example, we will use a sequence function where the first argument we will pass it as 1, the second argument we will pass it as 5, and the third argument we will pass it as 0. When we execute the statement, you can find that we have an error. So the third argument, that is the step argument or the by argument, cannot be 0. It has to be a positive number if the beginning of the sequence is less than the end of the sequence, or it has to be a negative number if the beginning of the sequence is more than the end of the sequence. That is when we are trying to generate sequence of numbers in reverse order. We have seen how to generate sequence of numbers, that is sequence of integer numbers, as well as sequence of floating point numbers. Now that we have seen how the colon operator and seq function works, let us summarize what we have learned. To generate a sequence of numbers from 1 to 10, we can use 1:10. To generate even numbers between 1 to 10, we can use 1:5 and multiply each element by 2. This is how we can get all the even numbers from 1 to 10. But how do you generate odd numbers? To generate odd numbers, we can use a sequence function. For example, we can have sequence, that is 1, 10, 2. That is, start the sequence from 1 till 10 and each time increment the element by step 2. Let us execute this statement. We can find that we have generated all the odd numbers between 1 to 10. Now suppose if I have to generate all the even numbers from 1 to 10 in reverse order. I can use a sequence function. The first argument I will pass as 10, that is the start of the sequence. Second argument I will pass it as 0, and then I will have step as -2 because I need to generate the sequence in reverse order. You can find that we have the sequence of all the even numbers generated from 0 to 10 in reverse order. Now suppose if I have to generate all the odd numbers from 1 to 10 in reverse order, we can use the sequence function with the first argument, which is the beginning of the sequence, as 9, and second argument, which is the end of the sequence, as 1, and the third argument as the step -2. We get the result of all the odd numbers from 1 to 10 in reverse order. So this is how sequence and colon operator can be used to generate sequence of numbers in R. In this video, we will look at how replicate function works. R provides an REP function which replicates the elements. The first argument is the value to be replicated, and the second argument is the number of times to replicate. Therefore, if I have to replicate an element certain number of times, I can use x followed by the assignment operator and then the rep function. The first argument is the value. So suppose if I want to replicate an element 1 5 times. So I will use first argument as 1, comma, second argument is the times equal to 5. And then let us try to print the value stored in variable x. We will execute these statements. You can find that the element 1 is replicated 5 times. Now we can also use characters. For example, let us use character z and replicate it 3 times. So we have the result as element z replicated 3 times. Let us look at another scenario. Suppose we have a sequence of numbers from 1 to 3. We will assign the sequence to variable x. Then we will have a variable y which uses a replicate function, that is rep, and we will pass the first argument as x, that is the sequence from 1 to 3, and then we will use times equal to, let's say, 5, and let us print y. We will execute the first statement. We have the sequence from 1 to 3 stored in variable x. We will execute the second statement, that is y with the assignment operator and replicate function, that is rep, and first argument is x, that is the sequence, and number of times is 5. You can find that we have the result as sequence of numbers which is replicated 5 times. So if you observe, we have a sequence from 1 to 3 replicated 5 times. We also have the second argument of rep function as each. Times argument replicates elements end to end, and each argument repeats each element before moving to the next element. So let us use the second argument as each. So we will have rep and the first argument as x and the second argument as each with the value assigned as 5. Let us execute these statements. Now you can find that the first value is repeated 5 times. Then the next element of the sequence, that is 2, is repeated 5 times. And then the third element of the sequence is repeated 5 times. So there is a lot of difference between the times argument and each argument. Remember that the times argument replicates elements end to end. So therefore we are having sequence repeated 5 times. Whereas the each argument repeats each element before moving to the next element. So in this case, the first element of the sequence is repeated 5 times. Then the second element of the sequence is repeated 5 times, followed by the third element of the sequence, which is again repeated 5 times. So this is how replicate or rep function works in R. In this video, we will talk about control structures. Control structures in R is used to control flow of execution of a series of R expressions or statements. There are 3 fundamental types of control structures that programming languages provide. Sequential control. Sequential control is an implicit form of control in which instructions are executed in the order that they are written. Selective control is provided by a control statement that selectively executes instructions. Common selective controls is if and else statements that are used to test a condition and execute R statements accordingly. In R we have if structure, if else structure, else if structure, and if else function. And the third control structure is the iterative control. Iterative control structure is provided by an iterative statements that repeatedly executes instructions depending upon a condition or sequence. The commonly used iterative control structure is a while loop, which executes statements while a condition is true. Repeat control structure, which executes statements infinitely, but must use a break statement to stop the execution. And the for loop, which executes statements for a fixed number of times. In this video, we will look at if if-else and else-if control structures. These control structures involve conditions or comparison operations which compare some value or operands. Then, based on some condition, they produce a Boolean result and act on it depending on whether it is true or false. We will first look at the if structure. Let us consider an example of writing a program to check whether a number is positive. We will declare a variable x and let us assign a value 5. We will use an if structure to check whether x is greater than 0. If it is greater than 0, that means it's a positive number. The syntax of if structure is, we use a keyword if followed by parenthesis where we provide the condition. In this case, the condition will be x greater than equal to 0. That is, when x is greater than equal to 0, it's a positive number. We will use curly brackets to open the body of the if structure. And here we will use a print function to print that the value in x is a positive number. Let us execute these statements. The first statement will assign value 5 to variable x. The second statement is the if structure. Here the condition x greater than equal to 0 is evaluated. That is, 5 greater than 0 is true. And the statements within the if structure executes only if the condition is true. In this case, the condition is true. So therefore the statement print positive number is executed and we have the output as positive number displayed. If the condition is false, the statements within the if structure are not executed and the statements following the if structure are executed. Let us have another statement. We will use print function print end of program. Now let us execute these statements. The first statement will assign value 5 to variable x. The second statement is the if structure. It will check whether x is greater than equal to 0. In this case, it is true. So the statement print positive number is executed and the statement following the if statement will be executed, that is end of program. The statements after the if statement will always be executed regardless of the condition is true or false. Let us take another scenario, that is x having value -2. We will execute the first statement which assigns value -2 to x. The second statement is the if structure where the condition x greater than equal to 0 is checked. X is -2, so -2 greater than equal to 0 is false. The statement within the if structure is not executed and the statement following the if structure is executed. And we have the display as end of program. Now suppose if we have to write a program to check whether a number is positive or negative. That is, to print the result whether the number is positive or the number is negative. In this case, we will be using if-else structure. So we have already written the if structure. We will now write the else part. Else followed by curly brackets and then we will have the statement as print negative number. Now let us execute this program. The first statement assigns a value -2 to a variable x. The second statement is the if structure where the condition -2 greater than equal to 0 is checked. This condition is false, so the statement within the if structure, that is line 3, will not be executed. An else part will be executed since the condition is false, and within the else part we have a statement print negative number. So we have the result displayed as negative number, and then the instruction or statements following the if structure are always executed, that is end of program. Now suppose if we have the value as 3 for variable x, we get the result as positive number and then finally end of program. Always remember that the statements after the if-else structure will always execute regardless of the condition is true or false. Now suppose if we have to check whether a number is positive or it's negative or is it 0. In this case, we can make use of else if structure. So we will have if part And then we will have else if and provide the condition. So we will start with the if statement and check the condition if x is greater than 0. And then we will have else if with the condition that is x less than 0. And the last statement we will have is else print 0 number. The else if statement can be used when there are multiple conditions to be checked. For example, here we need to check if x is greater than 0 or x is less than 0. Let us execute this program. We have assigned value 3 to variable x. The if condition is true, so print positive number will be executed. The else if part will not be executed because this condition is false. Even the else part will not be executed. And the statement following the conditional structure will be executed, that is print end of program. Now suppose if I have the value as -4, then the if condition is false, but else if condition is true, therefore print negative number will be executed and we have the output as negative number. And the statement following the conditional structure will be executed, that is end of program. Now suppose if I have the number as 0, that is x I am assigning value 0, then the if condition that is x greater than 0 is false, as well as the condition x less than 0 is also false. Then the else structure will be executed, that is we have the statement as print 0 number. And then the statement following the if structure will be executed, that is end of program. R also provides a special function, that is if-else function, which is very helpful and can be conveniently used to implement if-else structure. We will use the same scenario of writing a program to check whether a number is positive or negative number. So we will have a variable x and assign value 5. We will use if-else function. The first argument of the if-else function is the condition. In this case, we will have the condition as x greater than equal to 0. The second argument would be statement, which will be returned if the condition is true. In this case, we will have positive number. And the third argument will be statement, which will be returned if the condition is false. In this case, it is negative number. Let us execute these statements. The first statement will assign value 5 to variable x, and the second statement is if-else function, where the condition will be evaluated. That is, in this case, x is 5, 5 greater than equal to 0 is true, so the statement in the second argument will be returned. We will execute this program and we have the result as positive number. Suppose if we have the value of x as -4, in the if-else function, the condition, that is in this case x, which is -4 greater than equal to 0 is false, so the third argument will be returned as the value. So therefore we are having the output as negative number. Let us take another scenario to write a program to check whether a number is even or odd. Let us take value as 6, which is assigned to x. We will use the expression x modulus 2. The modulus operator is an arithmetic operator which returns the remainder of the division. In this case, x modulus 2 will give 0 if the number is even or 1 if the number is odd. We will check if x modulus 2 is equal to 0. Then if this is true, we will return even number. If it is false, we will return odd number. Let us now execute this program. The first statement will assign value 6 to variable x. And we have the if-else function which checks the condition, that is x modulus 2. In this case, the result of x, which is 6 modulus 2, is 0. So 0 equal to 0 is true. Therefore, the statement of the second argument, that is even number, will be returned. And we have the result displayed as even number. Now suppose if we have 7 as the value assigned to x, when we execute this program, we get the result as odd number. because x modulus 2, that is in this case the result of 7 modulus 2 is 1, which is not equal to 0. Since the first argument, that is the condition, is false, the statements in the third argument will be executed or returned. That is, we are having the result as odd number. Therefore, this is how the if-else function can be conveniently used to replace the if-else structure. In this video, we will cover loops, in particular for loops in R. For statement is an iterative control statement that iterates once for each element in a specified sequence of elements. The syntax of the for loop is, it starts with a for keyword and the open parenthesis, followed by a variable name, in this case let us use as I, and the in keyword followed by some sequence. In this case let us use the sequence as 1:5. And finally the closing parenthesis. We will open the body of the for loop using the curly brackets. The statements within the curly brackets forms the body of the for loop. The sequence for the for loop can be sequence of numbers or characters. It can be vectors, lists, matrices, and even data frames. The use of for loops with vectors, matrices, lists, and data frames will be covered later. Within the body of the for loop, we will have a print statement, that is print the element I. The body of the for loop, that is the print statement, in this case, will execute once for every element in the sequence. Let us execute this loop. You can find that each element of the sequence is retrieved at a time and displayed using the print function. So, for the first time, when the for loop is executed, the first element retrieved is 1, which is stored in I, and using the print function, the value stored in I is displayed. In the same way, the for loop executes till the end of the sequence, that is the last element is 5, which will be assigned to I, and when we are using the print function to print the value stored in I, we are having the output as 5. Once all the elements in the sequence are accessed, the for loop terminates. If we have a single statement in the body of the for loop, then there is no need to use curly brackets. But if we have multiple statements as part of the for loop, then we need to use curly brackets. If we have a single statement as part of the for loop, we can have for loop followed by that statement. In this case, it is print I on a single line. When we execute this, we get the same result. Now remember that to print any value which is stored in a variable, we can use a print function, as well as we could use the name of the variable itself. For example, in this case, I. But in for loop, we cannot use the variable I without a print statement. For example, if we have a for loop in this way, you can find that we do not get any output. So therefore, if we have to print the output, we need to use a print statement, that is print of I or any variable. We will look at another scenario. Suppose if we have a variable x, which is a sequence. So let us use the sequence as 1:10. And in the for loop, we can use a variable which contains a sequence. For example, in this case, it is x. Now when we execute these statements, you can find that we get the result, that is each element of the sequence displayed at a time. Let us look at another scenario. Suppose if I have a sequence of characters instead of numbers. For example, we will use x and assign letters, which is predefined constant. Now let me use for loop for I in x, that is retrieve every element of x and print that element at a time. Let us execute this program. You can find that the first statement assigns all the letters to variable x in sequence, and then the for loop will print each element or each alphabet at a time. So you can find that we have the output starting from letter A till the letter Z. Now suppose if we have to access only first 5 characters or only first 5 letters. Let us use y and assign the value of x, that is first 5 characters. And in the for loop, we will use, instead of I in x, we will use I in y. We will execute the first statement. Obviously, the first statement will assign all the letters to the variable x. The second statement will assign only first 5 characters or first 5 alphabets to the variable y. And here in the for loop, we are trying to retrieve each element in y, that is the first 5 elements, and print each element at a time. So when we execute this statement, you can find that first 5 alphabets or first 5 characters are displayed. So this is what is the basics of for loop. We will look in more detail about the for loop when we cover vectors, matrices, as well as list and data frames. In this video, we will cover iterative controls or loops, in particular while loop. Iterative control statement is a control statement providing the repeated execution of set of instructions. Because iterative control statements executes repeatedly, therefore they are commonly referred to as loops. Let us look at the syntax of a while loop. Before the while loop is encountered in a program, we need to have an initialization statement. So let us use I and initialize it to 1. The while structure is written using a keyword while, followed by the parenthesis. Within the parenthesis, we need to have a condition. For example, let us say I less than equal to 5, then followed by the body of the while loop. In the body of the while loop, we will have a print statement, printing the value of I. Always remember that in while loop, at some place in the body, we should have a statement which modifies the value of the initialization variable, that is in this case I, such that the condition in the while loop will eventually be false. In this case, we will have a statement I and increment the value of I by 1. So we will have I assigned to I plus 1. Let us execute this program. The first statement will assign the value 1 to the variable I. Here I is the initialization variable for the while loop, or it can also be called as a counter variable because it determines how many times the while loop executes. The next statement we have is the while loop. While loop will run only if the condition is met, that is if condition is true. In this case, we have the condition as I less than equal to 5. The condition in the while loop is checked. If true, the statements within the while loop are executed. So in this case, I is 1, which is less than equal to 5, which is true. Therefore, the statements, that is print I and I equal to I plus 1, will be executed. Each time when the end of the while loop is reached, the execution returns to the while loop condition to be checked again. When the condition is finally false, execution jumps past the while loop to the next sequential statement, and while loop is terminated. Let us execute these statements. Now you can find that 5 values are printed in the output. For the first time, I is assigned value 1. So the condition in the while loop, that is I, which is 1 less than equal to 5 is true. The print function will be executed, which prints 1. And then the next statement within the while loop, that is I equal to I plus 1, will be evaluated. In this case, we have I equal to, or I assignment operator, I plus 1, where I will be 1. So 1 plus 1 is 2. The value of I becomes 2. The end of the loop is reached. The execution returns back to check the condition. Now the value of I is 2. So I will be 2 less than equal to 5, which is true. Again, the statements within the while loop are executed. So the print statement, that is print of I, where now I will be storing value 2, will be executed. And we have the output as 2. Then the next statement, I will be assigned 2 plus 1, that is 3. The control again goes back to check the condition. And finally, we will have 5 less than equal to 5, which is true. So while loop will be executed, printing the value as 5. And then the value of I will become 5 plus 1, which is 6. The control goes back to check the condition. Now the I value is 6. So 6 less than equal to 5 is false. When the condition in the while loop becomes false, the while loop terminates. Always remember that the while structure will repeatedly execute the statements within the body of the while loop until the condition is false. Therefore, When the condition of the while loop is false, we exit the loop. One important aspect to take care inside the while loop is the modifying statement. Now, if we do not modify the variable which is used in the condition will never be false, and the loop goes into infinite execution. Therefore, infinite loops are iterative control structures that never terminates, and infinite loops are generally the result of programming errors. Therefore, always remember to modify the variable which is used in the condition so that while loop will not run infinitely. In this video, we will cover repeat loops. Repeat loops are also iterative control statements. Repeat loops also works the same way as while loops. The only difference is that a repeat loop should have a break statement such that the execution of the repeat loop will terminate. So in this case, we will have a variable I which we will assign the value as 1. Then the syntax of repeat statement or structure will start with the keyword repeat, followed by the curly brackets which forms the body of the repeat structure. We will have a print statement, print I, and then we will use an if statement to check the condition. That is, in this case, we will have if I is greater than 5, we will use a break statement. Remember that break is a keyword in R. And then, even in the repeat loop, we should have a statement at some place which will modify the variable used in the condition. So we will use I and assign the value as I plus 1. That is, we will increment the value of variable I. Let us execute the first statement. The variable I is assigned value 1, followed by a repeat structure. The repeat structure by itself will not have a condition. So we enter the repeat loop. The first statement in the repeat loop is a print I. The value of I is printed. Then the if statement is evaluated and condition is checked. In the condition we have I greater than 5. This condition is false because I is 1 and 1 greater than 5 is false. Break statement which forms part of the if structure will not be executed. Then the value of I is incremented, that is, I will be assigned a value 1 plus 1 which is 2. So now the value of I will become 2. At the end of the repeat structure, the execution goes back to the beginning of the body of the repeat structure. The print statement is again executed, which will now print the value of I which is 2. The if statement is executed and condition is checked. 2 greater than 5 is false. So break statement will not be executed, and then the value of I is now incremented, that is 2 plus 1 will become 3. This goes on until the value of I is 5, which the print function will print, and then value 5 greater than 5 is false. Break will not be executed, and the increment statement will increment the value of I, that is I will be assigned 5 plus 1 which is 6. So the control goes back to the beginning of the loop, print I, so we will have print 6 in the output, and then the condition in the if statement is checked, that is 6 greater than 5 is true, so break statement will be executed. Once the break statement is encountered, the loop terminates. Let us execute the repeat loop. When we execute, you can find that we are having numbers printed from 1 till 6. Now we have 6 also printed because when the value of I was 5, print statement printed 5, and then the if condition is checked, that is 5 greater than 5 is false. So break will not get executed. The value of I will become 5 plus 1 which is 6. We then go back to the first statement in the loop, that is print of I. Now the value of I is 6, therefore 6 is also printed. Then the condition is checked. Now suppose if we have to print only 5 numbers, then instead of having a print statement at the beginning or the start of the repeat loop, we will have the if condition, then we will have the print function, that is print of I. Now let us try to execute this program. You can find that numbers starting from 1 till 5 is printed. So this is how repeat loop works in R. Even in the repeat loop, we should have a statement which modifies the value of the variable which is used to check the condition. For example, in this case, we are modifying the variable I, which is used in the if condition. That is, in each iteration, we are incrementing the value of I such that at some point of time, the condition will become false and we exit from the repeat loop using the break statement. Remember that break statement has to be explicitly used in repeat loops. In this video, we will cover break and next statements. The while loop works until the condition is true and terminates once the condition in the while loop is false. In the same way, the for loops executes once for every element in the sequence. Break and next statements helps in partial execution of the loops. Once the break statement is encountered in a loop, the loop is exited. We have already seen the working of the break statement in a repeat loop. So here in the repeat loop, when the if condition becomes true, break statement is executed. And whenever in a loop, a break statement is encountered, the loop is terminated or loop is exited. On the other hand, when the next statement is encountered, the statements following the next statement in the body of the loop are skipped and the condition is re-evaluated. Depending upon the condition, the loop executes or sequence continues. Let us try to see the working of the next statement. Let us have a for loop for I in. Let us have a sequence from 1 to 10. I will have a print statement print I. When we execute this for structure, we will get all the numbers from 1 to 10 displayed. Now suppose if I have to display all the odd numbers between 1 to 10. We will use an if condition if and we will use the modulus operator. That is, we will have I mod 2. When the modulus operation is performed, it will return the remainder of the division. So in this case, when we are performing I modulus 2, we will get the remainder as 1 or 0. If the remainder is 0, it means it's an even number. So we will have if I mod 2 equal to 0, then we will have the statement as next. That is, if the condition in the if statement is true, that is, if the value of I is an even number, the statement within the if structure is executed. That is, in this case, we have next statement. When next statement is encountered, the statements following the next statement in the body of the loop are skipped and the condition is re-evaluated or sequence continues. So in this case, when the condition is true, that is, I is an even number, next statement will be executed and it will skip the statements following the next statement. And the control goes back to the for loop to continue with the next sequence. So now when we execute this for structure, you can find that we get all the elements with the odd numbers. Now suppose if I change the condition, that is I mod 2 equal to 1. When we execute these statements, you can find that we are having all the even numbers from 1 to 10 displayed. This is how the break and next statements works in R. In this video, we will cover functions. In addition to built-in function, R also provides the capability of defining new functions. Function takes some input, then produces some output. A function is just a piece of a code you can reuse. Function runs or executes only when it is called. If we define a function to do a task, we just have to call the function. You can think of a process like this. When we call the function 1, we pass an input to that function. The function has some statements which are executed. The function returns after the statements within the body of the function are executed. Subsequently, sequential lines of code are executed and the call to another function 2 may be made. When we call this function 2, the value is passed to another set of lines of code. The function returns after completing the execution of the statements within the body of the function 2. The process is repeated passing the values to the functions you call, and the functions can be reused. Now that we have gone over how to use functions in R, let us see how to build our own functions. Let us consider an example of writing a function to add two numbers. This is the syntax to create our own functions. The first line of the function definition is the function header. The function header starts with the function name, that is in this case sum, followed by the equal to symbol, and then the keyword function, followed by a list of parameters separated by comma within parentheses. The functions may or may not contain parameters. These parameters are also known as formal parameters. The closing of the parenthesis is followed by a curly brackets. After the function header, the statements within the curly brackets forms the body of the function. The body of the function, after executing the statements, may or may not return a value. To return a value, return statement is used. The return statement can also return any expressions. Let us consider the same example. This is our own defined function or a user-defined function, having sum as the name of the function. We have formal parameters a and b within parentheses. The first statement of the function performs the addition operation on two parameters passed. That is, in this case it is a plus b, and the result is stored in variable c. Then the function returns the value of variable c. After we define a function, we need to call the function to execute the statements within the function. To call the function, we use the function name with its parameters, if any, in parentheses. In this case, we are calling the function sum by passing the values 3 and 5 to the function. The parameters a and b will now hold the value 3 and 5 respectively. The first statement in the function will perform a plus b, that is 3 plus 5, and assign the result, that is 8, to variable c. Finally, the function returns the variable c. Actually, the value of the variable c is returned. If we call the function again, the process starts from scratch. Let us practically see how to create our own functions. For example, let us create a function with the name as mySum. This will be the name of the function, followed by equal to character, and then the function keyword or the function directive, followed by set of parameters within parentheses. In this case, we will have two parameters, that is x and y, followed by the curly brackets, within which we will have the statements which forms the body of the function. Let us have a statement as z and assign the value as x plus y. That is, we are performing the addition operation of the two parameters, that is x and y. We will use a return statement and return the value of z. The expression or variable which is returned should be within parentheses. Functions are often used to encapsulate a sequence of expressions that need to be executed numerous times. The functions allow a programmer to create an interface that is explicitly specified with a set of parameters. In this case, we have created a function mySum, and the set of parameters are x and y. To use this function, we need to call this function. Before we can use the function, we need to run the function code. The RStudio environment will load the entire function in the memory, that is, as a global environment, such that it can be called from any other file or through a console. So let us call the function using the function name, that is in this case mySum, and pass the arguments as 2, 5, and then hit enter. You can find that we have the result as 7, because 2 as an argument is passed to the parameter x, and 5 as an argument is passed to parameter y. And then the operation is performed, that is 2 plus 5, the result is 7, which is stored in variable z, and the last statement of the function will return the value stored in variable z, that is 7. So this is how we can use our own functions. The formal arguments are the arguments included in the function definition. For example, in this case, we have the arguments as x and y. R provides formals function, which returns a list of all the formal arguments of a function. So in the console, we can use formals and then pass the name of the function, that is my sum, within parentheses. We can find that all the arguments or parameters of the function MySum are displayed. Let us consider another scenario where we write our own function, that is MySum, to add three numbers. That is, let us consider that we have x, y and w. And we will modify the first statement to add three numbers, that is x plus y plus w, and store the result in variable z. Let us now run this program once more, and we will call MySum, passing the arguments as, let us say 4, 5, 7. We have the result as 16. Normally, when the call is made to a function, the arguments are matched positionally. Positional matching means that R assigns the first value to the first argument, the second value to the second argument, and so on. That is, in this case, we have first argument as 4, which is assigned to parameter x, the second value as 5, which is assigned to parameter y, and third value as 7, which is assigned to parameter w. In R, we can specify the function arguments by name. And when specifying by name, it does not matter in what order we pass the arguments. We have already seen passing the arguments by position. We will now look at how to pass arguments by name. So we will call MySum, and then we can say y and assign the value as, let's say, 4, and then x we can assign the value as, let's say, 5, w we can assign the value as, let's say, 7. If you look at the result, it is same, but the function is called using the named arguments. So in this case, the value of x will be 5, value of y will be 4, and value of w will be 7. We can mix positional matching with the matching by name. When an argument is matched by name, it is taken out of the argument list, and the remaining unnamed arguments are matched in the order that they are listed in the function definition. So we can use MySum and then call y equal to 4, w equal to 5, 7. Even in this case, you get the same result as 16, but we have called the function MySum using both positional as well as the named arguments. So in this case, the parameter y will be passed value 4, parameter w will be passed value 5 as a named argument, and finally we have parameter x which is left, and we are passing 7 as the positional argument to parameter x. The function's parameters optionally can have default values. For example, we can say x, y equal to, let's say, 2 and w equal to, let's say, 5. We will now call the function MySum by passing the value as 2, 4, 5. We get the result as 11. Now here, when you are passing the value to the parameters through the arguments, then default values will not be considered. So the parameter x will have a value 2 which is passed, parameter y will have a value 4 which is passed, and parameter w will have the value 5. Now suppose if I call the function MySum and only pass one argument which is 2, I'll get the result as 9. Now if you observe, what happens here is that the argument 2 is passed to the parameter x, and since we are not passing any parameters for y and w, the default value of y, that is 2, and default value of w, that is 5, will be considered. So we have x as 2 plus 2, that is 4, plus 5, which is 9. So therefore we are having the result as 9. Let us look at another scenario, that is MySum, and let us pass 3, 4. Now here we are passing two arguments, That is, the first argument 3 is passed to parameter x, the second argument 4 is passed to parameter y, and the default value is not considered. And then, since we do not have the third argument, the default value of w, which is 5, is considered. So here we have the result as 3 plus 4 plus 5, which is 12. Now we cannot just call the function mysum without any arguments. For example, mysum without passing any arguments. You can observe that we get an error. This is because the function has 3 parameters, but 2 of them are default. So therefore we need to provide at least one argument when calling the function. But suppose if I have all the 3 parameters of the function as default parameters, then I will be able to call the function without passing any arguments. And we get the result as 8 because all the 3 parameters uses default values. Always remember that when you create your own functions, or when you write new functions, or when you make changes to the existing functions, then you need to run the functions so that the functions are loaded in global environment. Let us look at another scenario with respect to the default parameters. Now let us consider that we have a default parameter, that is y equal to 3, and we have another default parameter, that is w equal to, let's say, 5. Let us run this function so that the function is loaded in the global environment. Now we can use mysum and then pass a value, let's say 3. We get the result as 11 because 3 is passed as an only argument. So the parameter x will be having value 3, whereas parameters y and w will be using default values, that is 3 and 5. So we have the result as 3 plus 3 plus 5, which is 11. Now suppose if I want to make x as a default parameter, so I will use x and assign the value, let's say 2, and y to be a normal parameter as well as w to be a default parameter. Since we have modified the function, let us load the function by using the run. Now suppose if I call the function mysum and pass the argument as 3, we will get an error. Now this is because we cannot assign default arguments arbitrarily or in any fashion. Please remember that when we are assigning default arguments, it has to start from the rightmost parameter till the leftmost parameter. Therefore, we cannot have the first parameter as the default parameter, the second parameter as the normal parameter. Suppose if we have to assign a default value to parameter x, then we need to use parameter y, comma, x as the default parameter and then comma, w as the default parameter. Since we have changed this function, let us run this function once more. And now we will call mysum and pass the argument as 3. You can find that you will get the result. So always remember that the default arguments or parameters cannot be assigned in any fashion. The default parameters has to start from the rightmost parameter and then can move on till the leftmost parameters. In R, we have a concept of lazy evaluation. For example, let us use the parameters as x, y, w, and we will have the same statements for the body of the function. Let us run this function so that it loads in the global environment. And then let me call this function using mysum and then passing the value as 1, 2, 3. We get the result as 6. In R, there is a concept of lazy evaluation. The arguments to functions are evaluated lazily, so they are evaluated only as needed in the body of the function. So, for example, in this case, if I use z equal to x plus y, though we are having 3 parameters, that is x, y and w, and the parameter w is nowhere used in the function. Let us run this function and then we will call this function using mysum and pass the values as, let's say, 10, 20. You can find that you are getting the result as 30 without any errors. This is because the function never actually uses the argument w anywhere in the body. So therefore, even when it is defined as a parameter, since it's not used, we do not get any error, and we use only 2 arguments to call the function. This concept is known as lazy evaluation in R. In this video, we will look at how a function returns multiple values. Let us call the function as myEval, followed by the equal to character, and then function as the keyword, and we will use x, y as 2 parameters. We will perform the operation of adding 2 numbers, that is x plus y. So we will have w equal to x plus y. That is the result of the expression x plus y will be stored in w. And we will have another variable z equal to, and we will have the expression as x multiplied by y. We need to use a return statement to return any value. For example, in this case we can return w, or we can either return z. But to return multiple values, we need to make use of list. So before returning, we will declare a variable as result, and then we will use a list function to club 2 values in one list and then return that list. So we will have result equal to list in parentheses. Let us try to have sum as the string, and we will assign the value using the equal to symbol w, which is the sum of 2 parameters x and y, and comma, let us have a string mul. We will assign variable z, which stores the result of multiplication of x and y parameters. And finally, instead of returning w or z, that is returning one value, we will return result. So result is a variable which actually contains a list having 2 elements, that is sum and mul. So now let us run this function to store it in a global environment, and then we will now call the function myEval, and let us pass the arguments as 2, 5. You can find that the function is returning multiple values, that is sum, which is 7, as well as mul, which is 10. In this video, we will look at inline functions or lambda functions in R. Suppose if a function has to perform a simple computation, we can use inline functions. The inline functions have the same syntax, except that the functions will not have multiple statements, and we will not use curly brackets to describe the body of the function. So let us write a function mySum, which is the name of the function, and then we will use function as the keyword, and in brackets we may or may not have parameters. For example, in this case, let us use 2 parameters, that is x, y, and then followed by space, not the curly brackets but the space, and then we will have x plus y. So this is how we define inline functions or lambda functions in R. Let us have another function, let's say myExp, followed by the equal to character, and then we will have function as the directive, and let us pass only one parameter, followed by let me compute x exponential 3. So these are the 2 functions we have created as inline functions. Let us first run these statements so that the functions get loaded in the global environment. Now we will be able to call functions, that is mySum, and we will pass value as 2, 4. We get the result as 6. In the same way, we can use myExp, and let us pass the argument as 3. We get the result as 27. So this is how inline functions or lambda functions can be implemented in R. In this video, we will show you how to create vectors in R programming language and different atomic vector types available in R. The most basic type of object available in R is a vector. Vectors are contiguous cells containing data. A vector is a one-dimensional array of objects which is used to store data. There are 6 basic or atomic vector types: integers, double, logical, character, complex, and raw. Integer, double, and complex are used to represent numbers, whereas logical is used to represent true or false values, character represents alphabets or symbols, and raw atomic type is used to represent raw data. There is no concept of variables having single values in R programming language. Everything in R is treated as an object. So a variable is still a vector of length 1. That is, single values or strings are still vectors of length 1. Vectors can only contain objects of same type. That is, all the elements of a vector must be of the same type. Let us have a look at two different values, 10 and 10.25. A value 10 is a whole number or an integer, and value 10.25 is represented as double. We can also have true or false, which is represented as logical atomic type, and a sequence of characters such as hello, which is represented as characters. R programming language provides type of function which can be used to find the type of data. For example, type of with the value of the data, in this case type of 10 will return the type as double. In the same way, type of 10.25 will return the type as double, which stands for floating point numbers. The type of function applied on hello as a string will return characters, and the type of true will return logical. Remember here, in this case, true is a logical value and not a string or characters, therefore it is not within quotes. Before we move on with the vectors, let us practically look at how the type of function works to know about the atomic types in R programming language. Let us consider a variable and we will assign a value 10. Let us use type of function on variable x. Let us execute these statements. The first statement assigns value 10 and the type of function will return the value as double. That is the atomic type associated with value 10. For example, if we have 10.25, here also you can find that the atomic type of value 10.25 is also double. Let us assign a value hello in single quotes to variable x. Now the type of function will return character as an atomic type for a string hello. To represent strings, we can also use double quotes. So if we have hello within double quotes, even in this case the type of function will return character. Let us use a logical value, that is, for example, let us use true. The type of function for true will return the type as logical. Instead of using true or false, we can also use T or F. Even in this case you can find that the result is logical. Let us now move on to learn how to create vectors. We have already seen how to assign values to variables using assignment operator, as well as using assign function. The most common way to create vector is to use function C, which stands for concatenate or combine, and this function can take multiple arguments. We can store the vector in a variable using the assignment operator. We can also use assign function to create vectors in combination with the C function. Let us use function C to create vectors. For example, in this case, we will have C followed by opening and closing of parentheses. Within parentheses, we will have certain elements. For example, in this case, we will have 10, 20, 30, 40. We can use an assignment operator to assign this vector to a variable or an object x. Let us print the contents of the vector which is stored in x. When we execute these statements, you can find that x is a vector containing 4 elements, that is 10, 20, 30 and 40. Let us use type of function on x. This will give us the result as double, since the vector contains all the elements of type double. We can also use assign function to create vectors. For example, let us use assign and then let us create an object with the name as y. We will use the second argument as a C function. Within parentheses, let us pass 50, 60, 70. and the next statement we will print the content of the vector y. Let us execute these statements. You can find that y is a vector containing 3 elements, that is 50, 60 and 70. The C function can also be used to create vectors of different types. For example, we can have a floating point vector, that is the elements as 10.25, 3.5, 8.75. When we execute these statements, you can find that we have a vector of floating point numbers. In the same way, we can create vectors of character type. For example, let us have an element as character A, the second element as character B, the third element, let's say, character Z. When we execute these statements, you can find that the vector is created which is of the type character. We can either use single quotes or we can also use double quotes to represent characters or strings. We can also create logical vectors where the elements can have only 2 values, that is true or false. For example, let's say first value as true, second value also as true, the third value as false, the fourth value is true. When we execute these statements, you can find that a logical vector has been created. Instead of using true false, we can also use T and F to represent true and false. For example, let us consider that we have 4 elements for a logical vector created using T and F, which stands for true and false. When we execute these statements, you can find that we have a logical vector with true and false as the elements created. Since vectors can contain elements of the same type, let us consider what happens if we create a vector with the elements as integers and strings. For example, we will use a C function, and then let us consider we have 10, 20 as the first 2 elements, the third element let us consider as A, and the fourth element let us consider as 3.5. We will execute these statements. You can find that the vector is of the type character even though we have integer as well as double values. This is because the integers and double values are implicitly coerced to a string. Vectors can only contain objects of same type, that is, all the elements of a vector must be of the same type. So therefore, the integers and floating point numbers are implicitly coerced to a string, and the result is a vector with all strings. It is not only integers or double or floating point numbers that are coerced to a string, we can also have logical types which will be coerced to a string. We can create a vector based on sequence of numbers. For example, we can have 1, 2, 3, 4, 5, 6. When we execute these statements, you can find that we have a vector with the elements from 1 to 6. The easiest way to create a vector of sequence of numbers is to use sequence or colon operator. For example, let us create a vector with the name as y and assign 1, 6. Let us print the vector. Let us execute these statements. You can find that a vector with sequence of numbers limited to 1 step at a time is created. We can also use a seq function, that is the sequent function, through which sequence of numbers can be created of variable steps. For example, let us have z as a vector and assign a seq function with the first argument as 1 and the second argument as 6. Let us print the elements within the vector z. When we execute these statements, you can find that we have the same result, that is a vector whose element starts from 1 and ends at 6. The first argument for the seq function is the start value. The second argument is the end of the sequence. We can also have the third argument, that is the step. So for example, let us use 1, 6, 2. Let us execute these statements. We can find that we have a vector with only 3 elements, that is 1, 3 and 5. Since we have used step as 2, each element is incremented by 2. We can also use REP function, which stands for replicate and is used to replicate elements of the vector. For example, we can have a value 10, times equal to, let's say, 3. When we execute these statements, you can find that vector with 3 elements created and each element has a value 10. We can also concatenate 2 vectors using the C function. For example, let us consider we have a vector as x which has value 10, 20, 30, and we have another vector y. Let us say that the elements of vector y are 3.5 and 8.45. Let us use another object, that is z, and assign the value using the C function, which takes in 2 vectors and concatenates them. Let us print the data stored in vector z. We will execute these statements. The first statement creates a vector x with 3 elements, that is 10, 20 and 30. The second statement will create vector y with 2 elements, that is 3.5 and 8.45. Third statement creates a vector z by using the C function, which concatenates 2 vectors x and y. So we have the result for the vector z containing 5 elements, that is 10, 20, 30, 3.5 as well as 8.45. In R programming language, we can create vectors using C function and assign the vector values to multiple objects in a single statement. For example, we can use Z, assignment operator, Y, assignment operator, X, assignment operator, and then we can use a C function to create a vectors. For example, let us have values as 1.25, 5, 3. And then we will print the values stored in vector x, y and z. When we execute these statements, you can find that the vector x, vector y as well as vector z will contain same elements. In R programming language, we can also use vector function to create empty vectors. For example, let us have x and assign the value using the vector function. We will print the value of vector x. When we execute these statements, you can find that a blank vector is created. We can also use vector functions to initialize vectors. In this case, the first argument of the vector function is the mode. So let us use the mode as numeric, and the second argument is the length. The default value for the length argument is 0. Let us use length and assign the value as 4. We will execute these statements. You can find that we have created a vector x with length 4 and all the elements are initialized to 0. The modes can be numeric, integer, logical, character, complex and raw. Suppose if we use logical, then we get the result as a vector where all the elements are initialized as false. Suppose if we use character as the mode, you can find that we have all the elements initialized as blank or null. So this is how vector function can be used to create and initialize vectors. Let us consider declaring an object x and assigning the value as 3 elements, that is 1.5, 3.25, 8.75. Let us display the elements of vector x. Let us execute these steps. You can find that we have created a vector x with 3 elements. To find the length of the vector, we can use length function. That is length of x. You can find that the length, that is the number of elements in vector x, is 3. Before we conclude this session, let us talk about the display in the console window. A vector can have any number of elements. In R programming language, there is no restriction or limit to the number of elements in a vector. And in R programming language, the index of vector starts from 1, not to 0. So therefore, this is what the 1 in square brackets in the output is indicating. That the first element of the row being displayed as the first element of the vector. Note that the single values or scalars do not exist in R. They are just treated as vectors of length 1. So this is how in various different ways we can create vectors in R programming language. In this video, we will talk about accessing the elements of vectors as well as performing indexing on vectors. Let us consider a vector x which has values 10, 45, 30, 50, 35, 40, 80. The elements of vectors can be accessed using the square brackets. The square brackets can also be used to access multiple elements of the vector. In R programming language, the index of vector starts from 1 rather than 0 in other programming languages. Therefore, x of 1 will give the first element. Let us execute these statements. When we are using x of 1, you can find that the first element of the vector is displayed, that is in this case 10. Within square brackets, we can also use negative indexes to exclude elements of a vector. For example, x of -2 will exclude the element at index 2 from the vector. When we execute this statement, you can find that we have all the elements of the vector except 45. We can also use colon operator within square brackets, which generates the sequence. For example, if we want to retrieve elements from the 3rd index till the 7th index, we can use 3 colon 7. When we execute these statements, you can find that 3rd element is 30. So starting from 3rd element till the 7th element is displayed. When we use colon operator within square bracket, the element at start of the index as well as the element at the end of the index is also included. We can also pass vector of indexes to retrieve elements of the vector. For example, within square brackets, we can have C function. And let us say that we want to retrieve elements at the 1st index, the 3rd index, the 4th index. When we execute this statement, you can find that the element 10, which is at the 1st index, is retrieved, the element 30, which is at the 3rd index, is retrieved, and element 50, which is at the 4th index, is retrieved. Let us use the function length to find the length of the vector. You can find that the vector is having 7 elements. Now suppose if I use x within square brackets 10. Now obviously the length of the vector x is 7, but I am trying to retrieve the 10th element. Let us execute the statement. You can find that we have the result as NA. When we try to access the element which is beyond the length of the vector, we do not get any error. Instead, we get the result as NA, which stands for not available. We can also use square brackets to replace the value of the element at a particular index. For example, if I use x of 2 and then assign the value as -8, and then we will display the vector. Let us execute these statements. You can find that the second element, which is 45, has been replaced with element -8. Now suppose if I try to replace an element at the index 10, which is beyond the length of the array, with a value as, let's say, 8. We will execute these statements. You can find that after the 7th element, that is element 80, the 8th and 9th element is NA, which is not available, and the 10th element is assigned the value as 8. Even in this case, we do not get any errors. Let us look at what happens if we assign a value of 8 at index -3. We will execute these statements. You can find that all the elements of the vector are replaced by 8 except the element at index 3. Always remember that when we use negative index, that index is excluded from the operation. So therefore here when we are assigning 8 to -3, that means except the element at index 3, all the elements should be assigned value 8. We can also use vectors of logical values to access elements. For example, x is a vector which contains 7 elements. Let us create a vector y which has logical elements. That is the first element as true, the second element as false, the third element as true, the fourth element as true, let's have the fifth element as false, the sixth element as true, and the seventh element as false. Now we will use the vector y to access the elements of vector x. So we can use x within square brackets, we can pass vector y. Let us execute these statements. You can find that since we are using a logical vector to access elements of another vector, that is, in this case we are using logical vector y to access the element of vector x. So when we retrieve the values of vector using the logical vector, the corresponding elements of the elements which are true of the logical vector will be retrieved. So therefore, in this case, the first element is true, so 10 is retrieved. The second element is false, so element 45 is not retrieved. The third element is true, so 30 is retrieved. The fourth element is true, so 50 is retrieved. The fifth element is false, so 35 is not retrieved. Sixth element is true, so 40 is retrieved. And the seventh element is false, that is element 80 is not retrieved. So therefore we have the result as 10, 30, 50 and 40. That is the elements of vector x corresponding to true indexes of element y. We can also use t and f to represent true and false. Now suppose if we have the first element as true, that is t, the second element as false, the third element as true. Now if you observe, the logical vector y is having only 3 elements. And the vector x has got 7 elements. Let us execute these statements. Now when we apply the logical vectors to access the elements of the vector x, you can find that since the logical vector y has got only 3 elements and the vector x has 7 elements, so the elements of vector y will be repeated in round-robin fashion. So when we apply this operation, we will get this result. Now let us try to trace. The first index is true, so 10 will be displayed. The second index is false, so 45 will not be displayed. Third index is true, so the third element, which is 30, will be displayed. Now for the fourth element in vector x, the first element of vector y is considered in round-robin fashion. So since it is true, the fourth element will be displayed, that is 50. Then the fifth element will not be displayed since the logical vector has a false value. Sixth element will be displayed, which is 40, since the value is true. And the seventh element will also be displayed since in round-robin fashion we again have true. So therefore, if the size of the logical vector is less than the size of the vector on which we are applying the operation, then the elements of the logical vector will be repeated in round-robin fashion and applied to the vector to access its elements. We can also use a for loop to access the elements of the vector in sequence. We can have for I in, let's say 1 colon length of x, and then we will use print x of I. Let us execute these statements. You can find that all the elements of vector x is retrieved. Instead of using the length function, we can also use the value, that is 1 colon 7. Let us execute these statements. You can find that all the 7 elements of the vector x are accessed. Now suppose if I use a sequence which is greater than the length of the vector, for example in this case 1 colon 10, you can find that we have accessed the 7 elements of the vector, and then the rest of the elements are displayed as not available. So when we access the elements beyond the length of the vector, we do not get any error. Instead we get NA for the elements which are not present in the vector. Instead of using colon operator to access the elements of the array through indexes, we can also use a function known as seq underscore along and pass the vector, that is x. seq underscore along stands for sequence along the vector x. When we execute these statements, you can find that we are able to access all the elements of the vector. Instead of using indexes to access, we can use for loop without the indexes. That is, for I in, we can directly use the object x, and then we can have, instead of x of I, we can simply have I. Let us execute these statements. You can find that we have accessed all the elements of the vector. Now in this case, I is not the index, it is the element of the vector itself. So this is how we can access the elements using the square brackets, that is the indexes, as well as we can use loops to access the elements of the vector. In this video, we will talk about matching operator which can be applied on vectors. The matching operator is a special operator which is preceded and succeeded by percentage symbol. For example, let us consider a vector x having 7 elements, that is 10, 45, 30, so on till 80. Now we can use the matching operator. For example, we will have 35 percentage in percentage and then x. Now here the matching operator works the same way as any other operator in our programming language. The matching operator, that is n operator, will check whether the element is present in a vector. So the first operand, in this case 35, is the element which we are checking whether it is present in the vector x. When we execute these statements, you can find that we get the result as true because the element 35 is indeed present in the vector x. But suppose if I have element 37 and execute the statement, we get the result as false, since the element 37 is not present in the vector x. Let us consider another scenario. For example, we have an object y which represents an element 30. Now we can use y in x. Let us execute these statements. You can find that we get the result as true because y is a vector containing only one element 30. And when we are performing y in x, we are actually checking whether the element 30 is present in the vector x. So therefore we get the result as true. Now suppose if we have vector y containing two elements, that is 30 and 35. Let us execute these statements. You can find that we get the result itself as a vector. That is, the result is a vector of two elements. The first element is true since 30 is present in the vector x. The second element of the resultant vector is also true since 35 is also present in the vector x. But suppose if we have, instead of 35, 37 and the third value, let us say 45. When we execute these statements, you can find that since 30 is present in the vector x, we get the result as true. 37 is not present in vector x, we get the result as false. And the third element, that is 45, is present in the vector x, therefore we get the result as true. So this is how a matching operator or n operator can be used in our programming language. In this video, we will look at vector arithmetics. Arithmetic operations can be performed on vectors. In this case, the operations are performed element by element. For example, let us consider a vector x having elements as 10, 45, 30, 50. Let us print the elements of vector x. We can perform the arithmetic operations on vector x, that is, we can use x plus, let's say 2. Let us execute the statement. The first statement will create a vector with 4 elements, that is 10, 45, 30 and 50. The second statement displays the elements of the vector, and the third statement performs the arithmetic operations on vectors. For example, here we have a vector x and we are performing the addition operation with a scalar value 2 on vector x. And we have a result as a vector where every element of vector x is added by 2. So we have the result as 12, 47, 32 and 52. When arithmetic operations are performed on vectors using scalar values, for example, in this case, we have 2 as a scalar value and x as a vector. The operation is applied on each element with the scalar value and the result is also a vector. Let us consider another example. Let us use x multiplied by, let's say 10. When we execute this statement, you can find that each element is multiplied by 10. We can also perform the sqrt function which returns the square root. For example, we can have sqrt of x. When we execute this statement, you can find that square root of each element of vector x is computed, and we have the result as displayed. Apart from applying arithmetic operations using scalar values, These operations can also be applied on different vectors as operands. For example, let us consider vector x with 4 elements. We will have another vector y, and the elements of this vector let us consider as 5, 1, 2, 4. And we can perform arithmetic operations on vectors, that is x plus y. Let us execute these statements. The first statement will create a vector x with 4 elements. The second statement will also create a vector y with 4 elements. The third statement will perform the arithmetic operation on vectors. That is, in this case, we have two vectors x and y, and we have the operator as addition. Even in this case, the arithmetic operation is performed element-wise. When we execute the statement, we have a vector with 4 elements. The value of the first element is 15. Since 10 plus 5 is 15, the value of the second element is 46. Since 45 plus 1 is 46, the value of the third element is 32. Since we have 30 as the third element of x and 2 as the third element of y, that is 30 plus 2, we have the result as 32. Then we have the last element of x, which is 50, plus the last element of vector y, which is 4, and we have the result as 54. The vectors occurring in the same expression need not be of the same length. Now here we have seen the example of performing arithmetic operations on two vectors, that is x and y, and length of both the vectors x and y are same, that is 4. But suppose if we have the length of vector y as 3 and the elements as 5, 1 and 2, and when we apply the arithmetic operation and when we execute these statements, we do not get any error. We only have a warning. And we have the result as a vector containing 4 elements. Now what happens here is, the first element of vector x is added with the first element of vector y, 10 plus 5, and we have the result as 15. The second element of vector x will be added by the second element of vector y, that is 45 plus 1, we get the result as 46. The third element is 30 of vector x, and third element of vector y is 2, that is 30 plus 2, we have the result as 32. Now, the fourth element of vector x is 50, but we do not have the fourth element for vector y. So therefore, the operation is performed by taking the element of vector y in round-robin fashion. So therefore, we perform the addition operation on the fourth element of vector x, that is 50, with the first element of vector y, which is 5, and we have the result as 55. We do not have any error, though we get a warning message. So this is how arithmetic operations can be performed on vectors using scalar values or using the vectors itself. As we have seen the function length of x, that is the number of elements present in a vector, we also have function as sum. The sum function will return the sum of all the elements of the vector. So we have the result as 135. That is 10 plus 45 is 55, plus 30 is 85, plus 50 is 135. In the same way, we have PROD function, which computes the product of all the elements of the vector. In this case, we have the result as displayed. We can also reverse the elements of the vector using the REV function, that is REV of x will give us the elements in reverse order. But do remember that the actual position of the elements in the original vector, that is x, will not be changed. We can also use sort function to sort the elements of the vector. In this case, sort of x will give the result as a vector in sorted order. Even in this case, do remember that the original positions of the elements of the vector are not changed. The sort function performs the sorting of the elements in ascending order. With the sort function, we can also use an argument as decreasing and assign the value as true. This will sort the elements in descending order. Apart from performing the arithmetic operations on vectors, we can also perform dot product of vectors. For example, let us consider that we have a vector x and we also have a vector y with the values as that is 5, 1, 4, 3. We can perform the dot product of two vectors using the special operator, that is percentage multiplication operator followed by percentage. So we will have the first operand as x, then the dot product operator followed by the second operand, that is vector y. Let us execute these statements. You can find that we have the dot product of two vectors, that is 365. Apart from using the special operator, we can also use a function known as cross prod, which stands for a cross product. And we can pass the arguments as vectors, that is x, y. When we execute this statement, you can find that we get the same result as dot product, that is 365. In R programming language, we can also perform the outer product of vectors. For example, we can use x, then percentage, O, percentage. This operator O within percentage symbol computes the outer product for vectors. So we will have x outer product y. When we execute this statement, you can find that we have the outer product computed for vectors x and y. We can also use tcrossprod function and pass the arguments as vectors x, y to compute the outer product of vectors. When we execute the statement, you can find that we get the same result. In this video, we will look at implicit and explicit coercion. The vectors may sometimes contain objects of different classes. For example, let us consider a vector x and assign the value as 10, the second element as a string or sequence of characters, third element as an integer, the fourth element as, let's say, a floating point number. Let us print the value of the vector. Here the vector x contains the first element of the type integer, the second element of the type string, the third element is also of the type integer, and the fourth element is of the type float. Therefore, the elements of this vector contains three elements of numeric class and the second element is of the character class. When a vector contains elements of different class or type, coercion occurs implicitly if R can figure out how to coerce an object so that every element in the vector is of same class. So when we execute these statements, you can find that we have a character vector since numbers can be easily converted or coerced into strings. Let us look at another scenario. Let us consider that we have a vector whose first element is an integer and the second element is a logical value, for example, true. When we execute this program, you can find that the logical values can also be easily coerced into numbers. The logical value true is coerced as an integer 1 and the logical value false is coerced as integer 0. Let us consider what happens when the vector contains an element of the type character and the second element of the type logical, that is true. Let us execute these statements. You can find that the logical value true is also implicitly coerced as a string. So therefore, numbers can be implicitly coerced into strings, and the logical values, that is true and false, can also be easily coerced into numbers as well as strings. If R cannot figure out by itself how to coerce an object, we can explicitly coerce objects from one class to another using as function, and the result NA is produced. Let us consider that we have a vector x. Let us print the elements of vector x, and then we will use a class function to find the class of vector x. Let us execute these statements. You can find that we have a vector x having 6 elements, that is 0 to 5. And the class of vector x is an integer. Let us use the as function, that is as dot logical, To explicitly convert the vector x, so we will use as.logical and pass the vector x as an argument. Let us execute this statement. You can find that the result is a logical vector where 0 is treated as false and any other element apart from 0 is treated as true. So here we have explicitly converted a numeric or integer vector x into a logical vector. In the same way, we can use as.character and pass the argument as x. This function will explicitly convert the integer vector into a character vector. When we execute this program, you can find that we have the result as a character vector, where every element is not numeric, it is a character. So therefore we are having the elements displayed with the double quotes. Let us look at another scenario. Let us consider that we have a vector x and this vector is of type character. So we will have an element, let's say John, the second element as Jack, and let us say the third element as Bob. We will find the class of this vector using class function and passing the argument as the vector x. Let us execute these statements. You can find that the class of the vector x is a character. We will use an as function, that is as dot. Let us use numeric and pass the argument as the character vector x. When we execute the statement, you can find that we have the values as NA. This is not an error, but it's a warning. In the same way, we can explicitly convert the character vector x into a logical vector using as.logical and passing the argument as a character vector. Let us execute this statement. You can find that the resultant vector contains 3 elements of the value NA. So this is how we can implicitly or explicitly coerce objects in R programming language. In this video, we will talk about logical vectors. In R, apart from arithmetic operators, we can also have logical operators, such as less than equal to, greater than equal to, and not equal to. These operators are actually relational operators. But since the result of applying these operators always produce a logical value, that is true or false, they are commonly known as logical operators. We also have AND, OR, and negation as part of the logical operators in R programming language. These logical operators can be used on vectors to generate logical vectors. The elements of logical vectors can have values true, false, as well as not available, that is NA. The logical vectors can be generated by using the conditions. For example, let us consider vector x and we will assign the elements as 10, 45, 30, 50, and 35. Let us print the elements of the vector x. We will consider a vector y and we will use the condition as x greater than 30. And then we will try to print the elements of vector y. Let us execute these statements. The first statement will create a vector x with 5 elements. We will execute the next statement, that is the vector y, which is assigned x greater than 30. You can find that the result is a logical vector. When this operation, that is x greater than 30, is applied, the relational operator, that is greater than, is applied on each element of the vector x. So therefore, 10 greater than 30 is false. So we have the first element of the vector y as false. The second element of vector x, that is 45 greater than 30, is true. So we have the second element of vector y as true. The third element, that is 30 greater than 30, is false. So we have the third element of vector y as false. In the same way, the fourth element is 50. 50 greater than 30 is true. So we have the fourth element of vector y as true. Then the last element, that is 35, of vector x is greater than 30. So we have the fifth element of vector y as true. So this is how relational operators can be applied on vectors using the scalar value to generate a logical vector. We can apply multiple conditions using the logical operators. For example, suppose if we want to find the range of numbers between 30 and 40. So we can use x greater than 30 and, that is the logical operator, x less than 40. Let us execute this statement. You can find that we have the result as a logical vector, and here only one element, that is the last element, is true. This is because 35 lies between 30 and 40. So this is the only element which meets this condition. So this is how we can also apply combination of relational operators. It is not only that scalar values, that is 30 and 40 in this case, that can be used with the relational operators on vectors, but we can also compare two different vectors. For example, let us consider the vector x having 5 elements, and let us have another vector y and assign the elements as 20, 15, 25, 65 and 5. And then we will have the statement, that is x less than y. Let us execute these statements. The first statement will create a vector x, the second statement will create vector y, and the next statement performs the comparison between the vector x and y. When we execute this statement, you can find that the result is a logical vector. When the relational operator is used with the vectors, the comparison is done element by element, and the result is a logical vector. So therefore, the first element of vector x, that is 10, is compared with the first element of vector y, that is 20. So 10 less than 20 is true, therefore we have the result as true. The second element of x and y are compared, that is 45 less than 15 is false. So we have the second element of the resultant vector as false. The third element, 30 less than 25, is also false. The fourth element, 50 less than 65, is true. And the last element, that is 35 less than 5, is false. So this is how relational operators can also be applied on different vectors. Now let us look at the operation of applying x greater than 30. Now when we execute the statement, you can find that we have the logical vector as the result. But suppose if we have to find which element of x is greater than 30, we can make use of which function. For example, we will use which, and as an argument we will pass the condition, that is x greater than 30. When we execute this statement, you can find that we have the output as the indexes of the elements which are greater than 30. So we have the result as a vector of indexes of the elements in x which are greater than 30. The first index is 2, that is the element at index 2, which is 45, is greater than 30. The next index is 4, that is the element at index 4, in this case it is 50, which is greater than 30. And index 5, that is the element at index 5, which is 35, is greater than 30. Now here we found out the indexes of which elements meets the condition. But suppose if we want to extract the elements itself which meets the condition, then we can use x of, that is in square brackets, function which, and within the parenthesis let us pass the condition, that is x greater than 30. When we execute the statement, you can find that we have the vector of elements which is greater than 30. In this video, we have seen how the relational operators are applied on vectors to get the result as a logical vector. We have also seen how to retrieve the indexes which match the logical true value, as well as the element which matches the logical true values of the condition specified. In this video, we will learn about the concept of factors in R programming language. Factors are used to represent categorical data. Factors can be treated as an integer vector where each integer has a label. Using factors as labels is much better than using integers because factors are self-describing. For example, having vectors that has values male and female is better than a vector having values as zeros and ones. Factors can be created using a factor function. Let us create an object x as a factor. To create x as a vector, we can use the C function. So let us use C. And the first element let us consider as male. The second element as female. The third element as, let's say, male. The fourth element also as male. And the fifth element, let us say, female. Now in this case, x is a vector. So let us display the values of x. You can find that x is a character vector. Let us create the object x as a factor. So we will make use of a factor function. That is factor, and in parentheses, we will pass the vector c. Let us execute this statement. You can find that the object x is now a factor, where these are the elements of the factor and we have the levels as female and male. That is, the object x, which is a factor, consists of only two unique elements, that is female and male. The levels displays the unique elements of the vector, in other case factored. R provides a table function which gives the count of the factors. For example, we can use table and then pass the argument as the factor x. Let us execute the statement. You can find that we have a table which consists of two columns, that is male and female, and we have the count of the factors corresponding to female as 2 and male as 3. What this means is, in a vector, female factor occurs 2 times and male factor occurs 3 times. So therefore, using factors is much better than using integers because factors are self-describing. In this video, we will look at the mathematical functions provided in R programming language. Let us create a vector. We will use x as a variable, and using the assignment operator and C function, we will create a vector with 4 elements. The first element let us have 4.258, the second element as -3.853, the third element as 5.457, and the fourth element as 7.504. Suppose if we want the vector x to have elements of absolute value, we can use the function abs. The abs function computes the absolute value of the element. So we can use the function abs, and the argument we will provide is the vector x. When we execute the statement, you can find that the second element of vector x has a negative value. And using the abs function, the negative value is converted into an absolute value. So therefore, all the elements of the vector will now have absolute values. We will now look at the ceiling function, which computes the ceil of the elements. So let us use ceiling and pass the argument as x, which is a vector. When we execute the statement, you can find that ceil values of the elements are computed. We will print the elements of vector x and then compute the ceiling value. When we execute these statements, you can find that the ceiling function returns the next integer corresponding to the element. For example, the first element we have is 4.258 and ceil of this value will be 5, that is the next integer. In the same way, we have the second element as -3.853 and the ceil of this value will be -3. For the third element, 5.457, the ceil value will be the next integer, which is 6. And for the fourth element, that is 7.504, the next integer is 8, therefore the ceil value is 8. In the same way, we can also compute the floor values. The floor function returns the smallest integer corresponding to the element. So we can use floor of x, and when we execute these statements, you can find that the first element of the vector is 4.258 and the floor value is the smallest integer corresponding to the element, that is 4. The second element is minus 3.853, so the smallest integer corresponding to the element minus 3.853 is minus 4. In the same way, the third element we have 5.457, and the smallest integer corresponding to this value is 5. And the fourth element is 7.504, and the smallest integer corresponding to this value is 7. In our programming language, we also have a round function. The round function is used to round the decimal places. For example, we can use round of x. When we execute the statement, you can find that the first element 4.258 is rounded to 4. The second element, that is minus 3.853, is rounded to minus 4. The third element 5.457 is rounded to 5. And the fourth element, that is 7.504, is rounded to 8. We can also provide the number of decimal places that we can use to round the elements. For example, to round the elements with 2 decimal places, we can pass the second argument as 2. When we execute the statement, you can find that the first element, that is 4.258, is rounded to 4.26. As the value in the third decimal place is 8, so therefore 258 is rounded to 26. In the same way, all the other elements of the vector are also rounded. Our programming language also provides a function trunc, which is used to truncate the floating point numbers to whole numbers. For example, in this case, the first element 4.258 will be truncated to 4. You can observe that the decimal digits of all the elements are truncated. Let us look at the difference between the round function and the trunc function. So we will use round function and followed by the trunc function. When we execute these statements, you can find that the truncate function simply removes the decimal digits, whereas the round function will round the number depending upon the decimal places provided. If the second argument for decimal places is not provided, then by default the round function will round the value to an integer. Our programming language also provides a function to compute the square root. For example, let us consider a vector x with 5 elements. First element we will have as 16, the second element as 36, third element as 30, fourth element as 81, and the fifth element as 25. We will use sqrt function to compute the square root of the elements of vector x. So we will have sqrt, in parentheses we will pass the vector x. We will print the vector x followed by the sqrt function. Let us execute these statements. You can find that the square root of the first element 16 is 4, the second element 36 is 6, and so on. Please remember that the sqrt function will always return the floating point number. To compute the exponential, we can use exp function. That is, exp of x will give the exponential values of the elements of vector x. We can also compute the logarithms using log function. For example, we can use log of x. When we execute these statements, you can find that log of 16, that is the first element, is 2.77, and so on. The log function computes the natural logarithms. We can use the base argument to compute log of respective bases. For example, we can pass the second argument as base and assign the value as 2. When we execute the statement, you can find that logarithm values of the elements for base 2 are computed. Instead of passing the base argument, we can also use the function as log2 to compute the logarithm with base 2. When we execute the statement, you can find that we get the same result. In the same way, we can compute the logarithm for base 10 using log10 as the function, or assigning 10 to base argument. When we execute the statement, you can find that we get the result of logarithm with base 10. Our programming language also provides a function factorial to compute the factorial of the elements. Let us consider a vector x having the elements as 4, 3, and 6. We will use the function factorial and pass the argument, that is the vector x. When we execute these statements, you can find that the factorial function has computed the factorial for 4, that is the result is 24, factorial for 3, the result is 6, and factorial for 6, the result is 720. When we try to compute factorial for negative values, we will get NaN as the result, which is not a number. So this is how various mathematical functions can be used which are provided in R programming language. In this video, we will learn how to generate random numbers. Simulation is one of the important aspects of statistics and for a variety of other areas. Sometimes we need sample of random numbers to simulate a system. R comes with a set of pseudo-random number generators that allows to simulate from well-known probability distributions like normal distribution, Poisson distribution, as well as binomial distribution. To generate random numbers, we can use rnorm function. Let us create a variable x, and using the assignment operator, we will have rnorm function. The argument to the rnorm function we will provide is value 10. In the next statement, we will display the elements of object x. When we execute these statements, you can find that we have 10 random numbers generated. The rnorm function by default will use mean as 0 and standard deviation as 1. We can provide the mean and standard deviation using the mean and SD as the arguments. For example, we can use the second argument as mean equal to 0 and the third argument as SD, that is standard deviation, and assign the value as 1. When we execute these statements, you can find that we get a different set of random numbers. In the same way, we can also provide our own mean. That is, in this case, let us provide the mean as 20 with standard deviation as 1. When we execute these statements, you can find that 10 random numbers have been generated using mean as 20 and standard deviation as 1. So this is how random numbers can be generated in R programming language. In this video, we will talk about matrices in R programming language. Matrices are vectors with dimension attribute. Matrices are two-dimensional vectors. The dimension attribute is itself an integer vector of length 2, that is number of rows and number of columns. Matrix contains elements of the same type. Matrix can be created using the matrix function provided in R programming language. The matrices are constructed column-wise and not row-wise. By default, the matrix function reorders a vector into columns. Some of the attributes of the matrix function are nRow, through which we can specify number of rows, nColumn, through which we can specify number of columns, and byRow, which takes in a logical value. The default value of byRow attribute is false. Let us practically see how to create matrices. We will use an object M, and using the assignment operator, we will use the matrix function to create a matrix. Let us try to create a matrix with 2 rows and 3 columns. So we will use nRow and assign the value as 2, and the second argument will be nColumn, that is nCol. We will assign the value as 3. Let us print the matrix M. We will execute these statements. You can find that the first statement creates a matrix with 2 rows and 3 columns. The second statement displays the elements of the matrix. In this case, since we have not provided any elements, by default the values of the elements are NA, that is not available. R provides a function dim which stands for dimensions. So we can use dim and pass the argument as a matrix M. When we execute the statement, you can find that we have the result as a vector with 2 elements. The first element specifies the row, that is in this case 2, and the second element specifies the column, that is in this case it is 3. Let us now use the matrix function to create a matrix with some values. So within the matrix function, we will pass a vector. We will use a C function and let us pass 6 values, that is 1, 2, 3, 4, 5 and 6. In the second statement, we will print the values of the matrix M. Let us execute this statement. You can find that we have a matrix with 6 rows and 1 column. This is because matrices are constructed column-wise and not row-wise. And by default, the matrix function reorders a vector into columns. Now suppose for the same elements, let us provide nRow and nColumn parameters. So within the matrix function, after the elements, the second argument we will use is nRow and assign the value as, let's say, 2. The third argument we will use is nColumn and let us assign the value as 3. Let us execute these statements. You can find that the matrix is created with 2 rows and 3 columns. and with the elements from 1 to 6. Even here you can find that the matrix is created column wise. Now let us also use the by row argument. So we will have by row and let us assign the value as true. When we execute these statements, you can find that now the matrix has been created row wise. We can also create matrices using vectors and dimension function. We will create object M, assign the values for the vector using the C function. This vector will have 6 elements from 1 to 6. Let us print the vector and execute these statements. You can find that a vector is created. We will use the dimension function to convert this vector M into a matrix. So we will have dim and pass the object M, and with the assignment operator and C function, we will assign the dimensions. That is, let us assign 2, 3. That means we are assigning the dimensions as 2 rows and 3 columns. Let us display the contents of object M. We will execute these statements. You can find that the vector is now converted into a matrix. Now suppose if we change the dimensions as 3, 2 and execute the statement, you can find that the matrix now has 3 rows and 2 columns. We can also create matrices using the matrix function and the sequence operator. For example, let us create an object M for matrix. With the assignment operator and matrix function, we will pass the sequence as 1, 6. Let us display the matrix M and we will execute these statements. You can find that the matrix is created with 6 rows and 1 column. We will provide the n row and n column attributes. We will assign n row as 2 and n column as 3. Let us execute these statements. Now you can find that matrix is created with 2 rows and 3 columns. In the same way, we can also use by row attribute and let us assign the value as true. When we execute these statements, you can find that the matrix is created row wise. Let us also create a matrix with a vector containing 12 elements. Let us use C function within the matrix function. Let us have the elements as 2, 3, 4, 0, 1, 2, -1, -2, -3, 5, 4 and 3. Let us use n row as 4 and n column as 3. We will also have the argument by row and assign the value as true. Let us execute these statements. You can find that matrix with 4 rows and 3 columns is created. Let us use the dim function. You can find that we have a vector with 2 elements specifying the number of rows and columns. To retrieve number of rows of a matrix, we can use a function nRow and pass the object, that is the matrix, in this case M. Let us execute the statement. You can find that matrix is of 4 rows. In the same way, we can use ncall function and pass the argument as M, which is a matrix. You can find that it returns 3 as number of columns for the matrix M. We also have a function length, and this function also takes in the argument as a matrix. In this case, it is M. Let us execute the statement. You can find that it returns the number of elements of a matrix. That is, in this case, it is 12. So this is how matrices can be created using the matrix function. Always remember that when a matrix is created, by default, it is created according to columns and not rows. We need to explicitly assign a logical value true to by row attribute or argument to make the matrix as a row wise. In this video, we will look at the diagonal function. The diagonal function is used to create or construct a diagonal matrix. Through the diagonal function, we can also extract the diagonal elements of the matrix. Let us create a matrix, that is M, using the matrix function. Matrix function will take 3 arguments. The first one is the value of the elements, and the second is the row, and the third is the column. So we will have the first argument as 4, which is used to fill the elements of the matrix. The second argument as, let us specify as 3, which is the number of rows. And the third argument, let us also specify it as 3, which is the number of columns. We will print the matrix using the object M. Let us execute this program. You can find that we have a matrix 3 by 3 created with all the elements with the value 4. Now suppose if we have to create a diagonal matrix, then we will use an object M and create the diagonal matrix using the diag function. The first argument of the diagonal function will be the value of the diagonal elements. Let us use as 1. The second and third argument will be the rows and columns. So in this case we will use 3, 3. Let us now print the matrix M. We will execute the statement. You can find that we have the diagonal matrix created with diagonal elements as 1 and rest of all the elements as 0. Let us change the value of the first argument of the diagonal function, that is, let us call it as 5, and execute the statements. You can find that now the diagonal matrix has been created with all the diagonal elements with the value as 5 and rest of the elements as 0. We can also create a diagonal matrix using the sequence operator. For example, suppose if we use 1, 3 as the argument for the diagonal matrix and execute the program, you can find that the diagonal matrix is created where the diagonal elements are 1, 2 and 3 and the rest of the elements are 0. In this scenario, we do not have to provide the rows and columns. The rows and columns are decided by the sequence. In this scenario, when we have sequence as 1, 3, that is a sequence of 3 elements, therefore the matrix will be of 3 rows and 3 columns. Suppose if we use 1:5, then the matrix will be created with 5 rows and 5 columns, and the diagonal elements will be of the sequence, that is 1 to 5. The diagonal function can also be used to extract the elements of the matrix. That is, suppose if we use DIAG and pass the argument as the matrix itself, that is, in this case we have already created a matrix M, and let us execute the statement. You can find that all the diagonal elements of the matrix has been extracted. Let us consider another scenario, that is a matrix created where all the elements are 4 and the rows and columns is 3. Let us execute these statements. In this case we have the result as all the diagonal elements as 4. So this is how we can use a diagonal function or DAG function to construct or create a diagonal matrix as well as extract the diagonal elements of the matrix. In this video, we will look at how to explicitly give the names for rows and columns of a matrix. Let us create a matrix, that is M, using the matrix function. We will assign the values for the matrix using the C function. Let us consider that we have elements of the matrix as 2, 3, 4, 0, 1, 2, -1, -3, and 5. The second argument of the matrix function would be n rows, that is number of rows. We will assign the value as 3. And the third argument will be number of columns, that is in this case n columns. We will assign the value as 3, and then we will have by row as the argument and set it as true. Let us print the matrix M. Let us execute these statements. You will find that we have a 3 by 3 matrix created. Now when you look at the columns, we have the default column names as well as we have the default row names. We can make use of the functions, that is row names and column names, to assign row names and the column names to the matrix. So let us use row names, and the argument we will provide is the matrix, that is M. We will use an assignment operator, and then we will construct a vector which contains the names of the rows. For example, in this case we have 3 rows, so we will provide the name as 1, 2 and 3, that is first, second and third row. In the same way we will use column names and pass the argument as the matrix itself, which is M, and then use the assignment operator with the C function to assign the names for the columns. In this case, the first column we will assign the name as A, the second column we will assign the name as B, and the third column we will assign the name as C. And then finally we will print the matrix. Let us execute these statements. The first statement will create a matrix. We will display the matrix. In this case, since we have not yet assigned the rows names and column names, we are having the default row names and column names. The next statement will assign the row names to the matrix M. The fourth statement will assign the column names to the matrix M. And finally, we will print the matrix. Now if you observe here, these are the column names which we have assigned using the column names function. And these are the row names which we have assigned using the row names function. Let us take another scenario. That is, let us consider that we have a matrix with only 6 elements and there are 3 rows and 2 columns. Now since we are using 3 rows, we can provide 3 different names, and whereas for the column names, since we have only 2 columns, we only have to provide 2 names. Let us execute these statements. You can find that we have assigned 2 column names as well as 3 different row names. So this is how we can use the row names function as well as column name function to assign user-defined rows and column names. In this video, we will look at how to access the elements of the matrix using indexes. Like vectors, matrices can be accessed using square brackets. However, since matrices are two-dimensional, we need to specify both rows and columns to access the elements. Let us create a matrix A using the matrix function. We will use the C function to create the elements of the matrix. In this case, let us consider the elements of the matrix as 2, 3, 4, 0, 1, 2, -1, -2, 5, 8, 6 and -3. We will use the argument nRow and assign the value 4. We will use another argument, that is nColumn, and assign the value as 3. We will create the matrix as row-wise, so we will use the argument byRow and assign the value true. Let us print the matrix A. When we execute the steps, you can find that we have created a matrix with 4 rows and 3 columns. Let us access the element of the first row and second column. We can use the matrix object A. Using the square brackets, we can pass row comma column, that is 1, 2 to access the element of the first row and second column. When we execute the statement, you can find that we get the result as 3. Suppose if we have to access the entire row of the matrix, we can use A of, that is in square bracket, 1, and we need not provide the column. When we execute the statement, you can find that we have accessed the entire first row. To access the third row, we can use A of 3, This will result in accessing the entire third row. In the same way, we can access the entire columns. For example, we can use A of, and we will not provide the row index. Instead, we will use A of, 2. In this case, the entire second column will be retrieved. R provides a function nRow which returns the number of rows of the matrix. So we can use A of nRow and pass A as the argument, and comma will give us the elements of the last row of the matrix. In the same way, we can use A of, nColumn, which will give us the elements of the last column of the matrix. We can also use negative indexes to access elements of the matrix. For example, when we use A of -3, the third row of the matrix will not be accessed. When we execute the statement, you can find that the third row of the matrix is eliminated. In the same way, we can eliminate the column by using the negative index on columns. That is, for example, A of, -1 will eliminate the first column of the matrix. When we execute the statement, you can find that the elements of the matrix is displayed without the first column. Using indexes, we can also change the elements of the matrix. For example, if we use A of 2, 3 and assign the value as 9, the element in the second row and third column will be changed to 9. When we execute the statement, you can find that the element in second row and third column is changed. We can also use sequences in place of indexes to subset more than one row or column at a time. For example, we can use A of 1, 3, 1, 2. When we execute the statement, you can find that first, second and third row of the matrix is accessed with first and second column. Let us look at another scenario. Suppose if we use A of 1, 3 for rows, -2 for columns, and when we execute the statement, you can find that the elements of first 3 rows with first and third column are accessed, thereby eliminating the second column. In the same way, suppose if we use A of -3, 2, 3, When we execute this statement, you can find that the elements of first, second and fourth row with second and third column are accessed. We can also use vectors to subset more than one row or column at a time. For example, we can use A of and then use the C function to create subset of, in this case, first row and third row, and execute this statement. You can find that the elements of first row and third row are accessed with all the columns. Similarly, if we use A of comma and the C function to subset more than one column, that is, in this case, C of 1, 3, and we get the result as a matrix of all the elements of all rows and the elements of column 1 and column 3. Till now, whatever statements we have used to access the elements of the matrix, we get the result of respective operations. But the structure and the elements of the original matrix is not changed. But suppose if we have to delete a row and a column of the existing matrix, then we can make use of the negative indexes and then assign the matrix to the original object. For example, to delete the second column of the matrix A, we can use A of comma minus 2 and then assign the value to the object A, which is a matrix. When we execute these statements, you can find that we have the original matrix displayed, and then the next statement will delete the second column from the matrix. And after execution of this statement, when the matrix A is displayed, you can find that we have the result as a matrix with the elements of 4 rows and 2 columns, where the elements of the second column is deleted. In the same way, we can also delete rows. For example, we can use A of minus 3 comma, and when we execute the statement, you can find that we get the result as 3 rows and 3 columns, where the third row of the original matrix is deleted. Suppose if we want to delete the third row and first column, then we can use A of minus 3 comma minus 1, and when we execute the statement, you can find that we have a matrix of 3 rows and 2 columns, where the third row and first column from the original matrix is deleted. So this is how we can use indexes to access the elements of the matrix, as well as we can use negative indexes to eliminate or remove elements of the matrix. Let us look at another scenario of using the diag function to access the diagonal elements of the matrix. In this case, you can observe that the matrix A is not a square matrix. It has 4 rows and 3 columns. So when we use the diagonal function to access the diagonal elements of the matrix A, you can find that the diagonal element is accessed starting from the first row first column to the third row third column. Let us look at another scenario of assigning the element to the matrix using the indexes which are beyond the rows or columns of the matrix. For example, if we use A of 5, 5 and assign the value as 10, and when we execute the statement, you can find that we get an error that is subscript out of bound. So therefore, you cannot access the elements or assign the values to the elements which are beyond the length of the rows and columns of the matrix. In this video, we will look at how to use rbind function and cbind function on matrices. Let us consider a matrix which has 3 rows and 3 columns. We will print the elements of the matrix, that is the matrix A. Matrices can also be created by combining vectors as rows using rbind function. Let us create an object B, and with the assignment operator, let us use rbind function. Rbind function, the first argument we will pass is the matrix A. The second argument will be the vector. For example, in this case, we will use the C function and pass the elements of the vector as 10, 11 and 12. And then we will print the matrix B. Let us execute these statements. You can find that we have used the rbind function to combine the elements of matrix A with the elements of the vector. Therefore, the matrix B will have the elements of the first 3 rows of matrix A with the elements of the fourth row as 10, 11 and 12. In the same way, we can use rbind function to combine 2 matrices. For example, let us create a matrix B using the matrix function with the elements as 10, 11 and 12. And this matrix will have 1 row and 3 columns. we will create an object C, and using the assignment operator, we will use the rbind function. The first argument of rbind function we will pass as the matrix A and the second argument as matrix B. When we execute these statements, the first statement will create matrix A and the elements of matrix are displayed. Then the matrix B is created, which has only one row, and the next statement will combine matrix A and matrix B using the rbind function. So the resultant matrix, that is C, will contain 4 rows and 3 columns. First 3 rows are from the matrix A and the last row is created from matrix B. In the same way, we can use cbind function to combine vectors as columns. Let us create an object B, and with the assignment operator we will use cbind function. The first argument of the cbind function we will pass matrix A, and the second argument we will use a C function with the elements as 10, 11 and 12. Then we will print the matrix B. Let us execute these statements. The first statement will create matrix A, which is displayed, and then we are using cbind function to create matrix B. When matrix B is displayed, you can find that matrix B contains elements of first, second and third column of matrix A, and the fourth column is created using the vectors which has the element 10, 11 and 12. We can also combine two matrices using the cbind function. For example, let us create a matrix B using the matrix function with the elements as 10, 11 and 12, and this matrix will have 3 rows and 1 column. Let us create another object C, and with the assignment operator, let us use the cbind function. The first argument of the cbind function we will pass matrix A and the second argument as matrix B. When we execute these statements, you can find that the first statement creates matrix A and it is displayed. Next, matrix B is created, which has 3 rows and 1 column. And then, when we are using the cbind function, matrix C is created, which has the first 3 columns as the elements from matrix A and the fourth column with the elements from matrix B. Now let us look at another scenario. Let us create a matrix B using the matrix function which has 4 elements, that is 10, 11, 12 and 13. And let us consider that this matrix has 1 row and 4 columns. We will print the matrix B, and then we will create an object C and assign the values using the rbind function. In the rbind function, we will pass the first argument as matrix A, the second argument as matrix B. In the next statement, we will print the matrix C. When we execute these statements, you can find that the first statement has created matrix A and it is displayed. The second statement creates matrix B and it is displayed. The next statement uses rbind function to combine two matrices, that is A and B. When we execute the statement, you can find that we have an error, that is number of columns of matrices must match. So therefore, when we are using rbind or cbind function on matrices, the dimensions of matrices must match, else we get an error. So this is how rbind or cbind functions can be used to combine vectors with the matrices or to combine two different matrices. In this video, we will look at operations on matrices. Let us create a matrix A using the matrix function, and we will have the elements of the matrix as 1, 2, 3, 4, 5, 6, 8, 9 and 1. And let us consider that this matrix is a 3 by 3 matrix. So we will have n row and assign the value 3 and n column and assign the value 3. And we will create this matrix as row wise. So we will use by row and assign the value as true. We will create another matrix B using the matrix function. And for this matrix, we will have the elements as 3, 1, 2, 4, 2, 1 and 5, 1, 2. And this matrix will also be 3 by 3, so we will have n row as 3 and the value of n column as 3. And we will create this matrix as row wise. So we will have the argument by row and assign the value true. Let us print the matrix A and B. R can be used to perform matrix calculations. For example, we can use A plus B. When we execute the statement, you can find that addition operation on matrices is applied. When the addition operator is applied on matrices, the addition operation is performed element-wise. So therefore, the element in first row first column of matrix A is added with the element of first row first column of matrix B, and we have the result as 4, which is the value of the first row first column of the resultant matrix. Similarly, respective elements of matrix A and matrix B are added and we have the resultant matrix. Similarly, we can use subtraction operation on matrices, that is, we can use A minus B, and even in this case the subtraction operation is performed element by element. In R, we can also use multiplication operator on matrices, that is, in this case A multiplied by B. But here the multiplication operator is not matrix multiplication, it is the element by element multiplication. That is, the element of first row and first column of matrix A is multiplied by the element of first row and first column of matrix B, and the result is stored as the first row and first column of the resultant matrix. Similarly, the respective elements of matrix A is multiplied by the respective elements of matrix B, and we have the resultant matrix. To perform matrix multiplication, we have a special operator, that is percentage multiplied by percentage. So therefore we can use A percentage multiplication operator percentage then the matrix B. When we execute the statement, we get the result of matrix multiplication. We can also use division operator, for example A divided by B. Even in this case, the division is performed element by element. So, the element of the first row and first column of matrix A is divided by the element of first row and first column of matrix B, and the result is stored in the first row and first column of the resultant matrix. And similarly, respective elements in the rows and columns of matrix A are divided by respective elements in the rows and columns of matrix B. In R, to perform the transpose of a matrix, we can use the function T. For example, we can use the function T and pass the argument as the matrix. In this case, it is A. When we execute the statement, you can find that the transpose of matrix A is computed, where the first row becomes the first column, the second row becomes the second column, and the third row becomes the third column. We can also use solve function, which returns the inverse of the square matrix if it is invertible. For example, solve of matrix A, and when we execute the statement, and we will have the resultant matrix as the inverse of matrix A. In this video, we will look at matrix-specific functions. Let us create a matrix A using the matrix function, and the elements we will use as the sequence, that is 1, 9, and this matrix will have 3 rows and 3 columns. Let us display the matrix A. In R, we have a function row sums. For example, we can use row sums and pass the argument as matrix A. When we execute the statement, you can find that row sums function will return a vector whose length is equal to number of rows. The sum of all the elements of the first row are computed. In this case, the sum is 12, which is the first element of the row sum vector. Similarly, the sum of second row is 15 in this case, which is the second element of the vector, and the sum of elements of the third row is 18 in this case, which is the third element of the vector returned by row sums. In the same way, to find the sum of the elements of the columns, we can use COL sums function and pass the argument as the matrix A. When we execute the statement, column sum functions will return a vector whose length will be equal to the number of columns of the matrix. So, the sum of the elements of the first column is 6. That is the first element of the vector returned by column sums. In the same way, the sum of elements of the second column is 15, which is the second element of the vector, and the sum of elements of the third column is 24, which is the third element of the vector computed through column sums function. In the same way, R also provides a function row means, which takes the argument as vector, and in this case it is vector A. When we execute these statements, you can find that the row means function returns a vector whose length is equal to the number of rows of the matrix. The first element of row means vector computes the mean of all the elements of first row. In this case, we have the value as 4. In the same way, the mean of all the elements of row 2 is computed and we have the value as 5. And the last value of the row means vector is 6, which is the mean of elements of the third row of matrix A. In the same way, we have column means function, which computes the means of the elements in the column. The value of the first element of column means is 2, which is the mean of elements of the first column of matrix A. In the same way, the second element of the column means vector is 5, which is the mean of the elements of second column of matrix A. And then we have the third element, which is 8, of column means vector, which is the mean of the elements of the third column of matrix A. R programming language also provides a function apply which can be used on matrices. For example, we can use the function apply, and the first argument of the function is the matrix, which is A in this case. The second argument is the dimension. Let us provide 1, and the third argument is the operation. In this case, it is sum. When we execute these statements, the first statement creates the matrix, and then when we execute the apply function will compute the sum of the rows of the matrix A. The sum of the rows are computed because the second argument is provided as 1, which represents rows. When we use the second argument as 2, which is used for columns, we get the sum of the elements in the column. So this is how matrix-specific functions can be applied on matrices in R programming language. In this video, we will look at the list in R programming language. Lists are special type of vectors that contain elements of different type. They are also collection of data and another kind of data storage. List is a one-dimensional, heterogeneous data structure. List can contain elements of any type of R object. List can also contain vectors as elements. Elements of the list need not be of the same type. List can be created using the list function provided in R programming language, which takes arbitrary number of arguments. Let us practically see how to create lists. Let us create an object X, and using the assignment operator, we will use the list function. Let us consider the first element of the list is an integer, that is 10. Let us consider the second element as a sequence of character or string, for example, let us say John. And the third argument, let us consider a logical value, for example, true. Let us print the list X using the X object. Let us execute these statements. The first statement will create the list X, and the second statement will display the elements of the list X. The elements of the list are denoted using the double square brackets. For example, the first element is at index 1, that is 10. The second element is at index 2, that is John. And the third element is at index 3, that is the value true. Let us now look at how to create list using vectors. Let us create an object roll number, and using the assignment operator with the C function, let us create the elements for the vector roll number. We will have the elements as 101, 102 and 103. Let us create another vector known as sNames. We will use the assignment operator with the C function to create the elements for the vector as sName. Let us have the first element as John, the second element as Bob, and the third element as Alice. Let us create another vector and we will call this vector as marks. Again, using the assignment operator and the C function, we will create the elements for the vector marks. Let us have the first element as 78.25, the second element as 59.45, and the third element as 63.85. Now here we have three vectors, that is roll number, sname and marks. We will create a list with the name as students. We will use the assignment operator and then use the list function. In the list function, we will pass the argument as the roll number, which is a vector. The second argument we will pass as snames, which is also a vector. And the third argument we will pass it as marks. Now if you observe, the roll number vector is of the type integer. The sname vector is of the type character and the marks vector is of the type floating point numbers or double. And we have created a list as students with vectors of different type. Let us now try to print the elements of the list, that is students. We will execute these statements. The first statement will create a vector roll number. The second statement will create a vector snames. The third statement will create a vector marks. And the fourth statement will create students as a list. And the next statement will print the elements of the list. You can find that for the list, the first element is the vector itself. The second element is also a vector, but it is of the character type. And the third element of the list is again a vector of the type double. So this is how vectors are created in R programming language. Instead of creating different vectors and passing them as the arguments for this list function, we can directly use C functions within the list function to create lists. Let us look at how this can be done. Let us consider that we are creating students as the list. We will use the list function, and within the list function, we will use the C function. That is, let us create a vector for the first element of the list. For example, within the C function, we will have two elements, that is 101 and 102, comma. The second element of the list, again we will use the C function, and let us try to create a character vector. For example, let us say Bob, and then let us have the third element of the list again as a vector using the C function. We will have the values as 78.25, 59.65, 63.45. Let us execute these statements. The first statement will create a list with three elements, and then the next statement will display the elements of the list. You can find that the first element of the list is a vector with two elements. The second element of the list is a vector of type character with only one element. And the third element of the list is a vector of type double with three elements. So we can also create lists with the elements having different lengths. So these are the two ways in which we can create lists in R programming language. In this video, we will look at how to perform list indexing. The lists in R programming language are indexed the same way like vectors, but each element may contain an element of any type. We can access the elements of the list using the square brackets. Let us create an object roll number, and using the assignment operator with the C function, let us create the elements for the vector roll number. We will have the elements as 101, 102, and 103. Let us create another vector known as snames. We will use the assignment operator with the C function to create the elements for the vector as sname. Let us have the first element as John, the second element as Bob, and the third element as Alice. Let us create another vector and we will call this vector as marks. Again, using the assignment operator and the C function, we will create the elements for the vector marks. Let us have the first element as 78.25, the second element as 59.45, and the third element as 63.85. Now here we have three vectors, that is roll number, sname, and marks. We will create a list with the name as students. We will use the assignment operator and then use the list function. In the list function, we will pass the argument as the roll number, which is a vector. The second argument we will pass as sNames, which is also a vector. And the third argument, we will pass it as marks. To access the elements of the list, we can use square brackets. For example, let us use students of 1. Let us execute these statements. The first statement will create vector as a roll number. The second statement will also create a vector as sName. And the third statement will create a vector as marks. The next statement, where we are using list as the function, will create a list as students. When we use students of 1, we will be accessing the first element of the list. In this case, the first element of the list is a vector. So therefore, we have the result as elements of the vector. We can also use double square brackets, that is students of double square brackets 1. And when we execute the statement, we get the result as a vector, which is the first element of the students list. Let us look at what is the actual difference when using a single square brackets and a double square brackets to retrieve the elements of the list. For example, let us try to use students in single square brackets of 1. And the next statement we will have as students with double square bracket as 1. Let us execute these two statements. If you observe, using the single square bracket will return a list, but whereas using the double square bracket will return an elements of the list. So therefore, when we use double square brackets, we will be able to access the individual elements of the vector inside a list. For example, suppose if I have to access the element 102 from the students list, I can use students in double square brackets, the index as 1, which represents the first element of the list, and 102 is the second element of the vector. So we can use in square brackets index 2. When we execute the statement, you can find that we have retrieved the second element of the vector, which itself is the first element of the list. In the same way, using the indexing, we will be able to change the elements of the list. For example, let us print this list and then we will use the indexing, and let us try to use students in double square brackets. Let us pass the index as 1 and then we will have a single square brackets and let us pass the index 2. We will use the assignment operator and then assign a value. For example, let us say 109. We will again print the students list. Let us execute these statements. We will execute the statement which prints the list of the students, and then the next statement will change the element of the list, and then again we will print the elements of the students list. You can find that earlier value was 102 as the first element of the list and second element of the vector, which has been changed to 109. So this is how we can use indexing to access the elements of the list, as well as we will be able to change the elements of the list using the indexing. Always remember that even the index of the list will start from 1. In this video, we will look at how to name the elements of the list, as well as how to use the subset or the dollar operator to access the elements of the list. Let us consider that we have three vectors, that is roll number, sName and marks. And using the three vectors, we have created a list using the list function and passing the vectors as the arguments. Names can be assigned to the elements of the list. For example, let us consider assigning names to the students list. Let us assign the name as IDs to the first element of the list, that is roll number. We will use in single quotes the name, that is, in this case it is ID, and we will use the equal to operator. And for the next element, we will use name and assign it to sNames, which is a vector. And third element, we will use the name as scores and assign it to the vector marks. Always remember that the names which have been assigned are strings or sequence of characters. Now we will be able to use the subset operator or the dollar operator to access the elements of the list. For example, we can use students followed by the dollar sign or the subset operator, and then we can use ID to access the first element of the list. Let us execute these statements. You can find that when we have used students $ID, we have retrieved the first element of the list using the name, that is ID in this case. In the same way, we can access scores, that is students followed by $ and scores, which is a name for the third element. When we execute the statement, you can find that the third element, which is a vector marks, is now using the name as scores. And we have retrieved the value of the third element of the list. The $ operator or the subset operator is used to access the elements of the list by name. We can also use the C function to access the elements of the list. For example, we can use students, and then within square brackets, we can have a C function. Let us use the index as 1, 3. When we execute the statement, you can find that the first element of the list, that is, with the name ID, is retrieved, as well as the values of the third element of the list with the name as scores are retrieved. We can also use the names within the C function. So for example, instead of using 1, 3, we can use first name as ID, within quotes, comma, and within quotes, let us try to retrieve scores. When we execute the statement, you can find that we have the same result. So this is how we can name the elements of the list, as well as we can use the $ operator or the subset operator to access the elements of the list by name. In this video, let us look at how to perform concatenation on lists. Let us consider that we have three vectors, that is roll number, sname, and marks, and we are creating a list students using the list function and passing three vectors, that is roll number, sname, and marks. Let us create another list. Let us call this list as age. We will use the assignment operator and the list function. In the list function, we will create a list having only one element using the C function. Let us consider that we have the elements as 19, 20, 18. So now we have created student as one list which has three elements, that is roll number, sname, and marks, as well as we have created a different list with the name as age. We will now be able to combine or concatenate these two lists using the C function. For example, we can use student and then we will use the assignment operator with the C function. Within the C function, we will pass the first argument as students and the second argument as age. Let us print the students list before concatenation, as well as after the concatenation, we will again print the students list. Let us execute these statements. The first statement will create a vector roll number. The second statement will create a vector sname. The next statement will create a vector marks. And then the next statement will create students as a list with three vectors. We will display the list. You can find that this list has three elements. Then the next statement will create a list as age. And finally, we are using a C function to concatenate two lists, that is student and age. So when we execute this statement, the students list is concatenated with the age list. And when we display the elements of the student list, you can find that the student list is concatenated with the elements of the age list. So this is how we can perform the concatenation operation on different lists. Please note that the multiple lists can be concatenated using the list function. In this video, we will learn about data frames in R programming language. The vectors and matrices in R is used to store data. R programming language also provides data frames which also stores data in rows and columns. That is, data frames are used to store tabular data in R. Data frames are just like list objects. Unlike matrices which stores elements of same data type, a data frame may contain elements of different data type. The data frame represents special type of list, where each element of the list can be thought of as a column. A data frame is also a list of vectors, so each vector must contain elements of same type, but different vectors can store elements of different types. When we compare list and data frames, components of list must be vectors, but in data frames, column may possibly be of different type. Unlike list, which can have vectors of different lengths, the data frame must have all vectors of same length. Data frames can be created using data.frames function. This is one way of creating data frames. We can also import data from various file types into data frames. That is, data frame can be created by reading dataset using the read.table function or read.csv function. Using read.table function, we can import data into data frames from text files. And by using read.csv function, we can import data from comma-separated files. So to sum up the theoretical aspect of data frames in R programming language, the data frame is an important data structure in R, especially for statistics. The basic structure of a data frame is that there is one observation per row, that is, it contains rows, and each column represents a variable or an attribute or a measure or characteristic of an observation. Let us practically look at how to create data frames in R programming language. Let us consider that we are creating data frames using three attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame, and then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name and marks. Let us now display the data frame, that is students. Let us execute these statements. First statement will create a vector ID with 3 elements. The second statement will create a vector as name, also with 3 elements. And even the third statement will create a vector marks. Even this vector will have 3 elements. The next statement will create a data frame which is represented with the object as students. And finally, we will print the data frame, that is students. If you observe the output, you can find that each vector is treated as a column in the data frame, and the corresponding elements of the vectors are treated as rows. So therefore, since each vector has 3 elements, we have 3 rows for the data frame. Now before we move on with the other aspects of data frames, let us look at the difference between data frames and lists in R programming language. Let us create a list with the same vectors, that is ID, name and marks. So we will have an object slist, and using the assignment operator and list function, we will create a list. In the list function, we will pass the 3 vectors, that is ID, name and marks. Let us print the list, that is in this case slist. Let us now execute these statements. The first statement will create a vector ID with 3 elements. The second statement also will create a vector, that is name, with 3 elements, as well as the third statement will also create a vector marks with 3 elements. The next statement will create a data frame, that is students, and then for time being we will not display the data frame, instead we will create a list. So when we execute this statement, you can find that list has been created with 3 vectors. Let us display the contents of a data frame as well as the list. And if you observe, data frame and list both are created using the same vectors. Let us display the data frame and we will now display the list. So if you look at the output, you can find that each vector in a data frame is treated as a column, whereas in a list, each vector is treated as a row. And if we consider the real world scenario, having each observation per row and treating attributes or observation as columns is much more convenient. Therefore, using data frames for large set of data for evaluation is much better than using list in R programming language. In this video, we will look at how to access the elements of data frame using indexing. Let us create a data frame to demonstrate how indexing works. Let us consider that we are creating data frames using three attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame, and then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name and marks. Let us now display the data frame, that is students. Let us execute these statements, and finally we will print the data frame, that is students. The elements of the data frame can be accessed using square brackets. To access the entire row of a data frame, we can use the data frame object and within square brackets the index of the row. For example, let us use students. In square brackets, let us try to access the second row. So we will provide index 2, comma, and we will not provide any index for the columns, since we are accessing the entire row. Let us execute this statement. You can find that the entire second row has been accessed with all the columns and attributes of the data frame. Suppose if I have to access the second and the third row, we can use the colon operator. For example, we will have the students object, and within square brackets, we will have the index as a sequence, that is 2 colon 3, and we will not provide any indexes for the columns or attributes. Let us execute this statement. You can find that entire second and third row has been accessed with all the columns and attributes of the data frame. In the same way, we will be able to access the entire columns. For example, to access the entire first column, we will use the data frame object, and within square brackets, we will not provide any index for the row, comma, but we will provide the index for the column, that is in this case index 1. Let us execute this statement. You can find that the entire first column of the data frame has been returned as a vector. Let us consider another scenario. Suppose if I have to access the second and the third row and first two columns or attributes. In this case, we can use the rows as a sequence 2 colon 3, comma, and the attributes or column as a sequence of 1 colon 2. Let us execute these statements. You can find that the second and third row has been accessed with first and second attribute or column. We can also use negative indexes to eliminate the row or the column of a data frame. For example, suppose I want to eliminate the second row and third column, then I can use -2 as the index for the row and -3 as the index for the column. Let us execute these statements. You can find that this statement has eliminated the second row and third column, and we have the display as the first and the third row with first and second column. But suppose if we provide only one index within the square brackets, we will just be referring to the column. For example, if we have students of 2 and execute the statement, you can find that the entire second column has been retrieved. The single index within square bracket just refers to a column. We can also use C function to subset rows or columns. For example, we can have C of indexes 1, 3 for the rows, and then comma, we can use C of, let us say 2, 3, which are the indexes for the columns. Let us execute this statement. You can find that the first and the third row has been retrieved with second and the third column. We can also use double square brackets such as, which returns an element of the data frame. For example, to access the element which is at first row and third column, that is 78.25, we can use students of double brackets and then provide the column, that is in this case 3, followed by closing of the double square brackets, and then we have to use a single square brackets and provide the index for the row, that is in this case index 1. When we execute the statement, you can find that the element at the third column and first row has been accessed. We can also use $operator to access the elements of the data frame by name. For example, we can use the data frame object, in this case it is students, followed by $, and then the name of the attribute or the column. For example, in this case, let us use marks. Let us execute the statement. You can find that all the elements of the marks column or attribute has been retrieved as a vector. Through the $operator, we can also access the individual elements. For example, to access the third element of the marks column, we can use students $marks followed by square brackets and index 3. When we execute this program, you can find that the third element of the column's attribute has been accessed. As we can use square brackets to access the elements of the data frame, in the same way we can use square brackets to update the elements in the data frame. For example, let us update marks in the second row and third column. So we can use the data frame object, that is in this case students, followed by double square brackets, and since double square brackets takes index for the columns, so we will provide the index as 3, followed by again square brackets, and we will provide the index for the row as 2. And then using the assignment operator, we will update the element with the value as, let's say 24.00. Let us again print the contents of the data frame object, that is students. We will execute these two statements, that is the statement which updates the value, and then we will again display the contents of the data frame, that is students. You can observe that the element 59.45 has been changed to 24.00. So these are the different ways in which we can access the elements of the data frame. In this video, we will look at how to use subset function on data frames. We will create a data frame to know how subset function works. Let us consider that we are creating data frames using 3 attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame, and then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name and marks. Let us now display the data frame, that is students. Let us execute these statements. And finally, we will print the data frame, that is students. Subset function returns a subset of data frames which meets the conditions. Let us create an object report, and with the assignment operator, we will use the subset function. The first argument is the object to be subsetted, that is in this case it is students. The second argument is the subset condition, which is a logical expression. This argument is optional, and if it is not provided, then the expression is by default considered as true. For the second argument, let us provide a subset condition, that is marks greater than 60. Let us print the report object. We will execute the statement that displays the data frame, that is in this case students. We will execute the next statement which uses the subset function. The subset function returns the data based on the subset condition. This data is stored in an object, in this case it is report. And then we will execute the statement which displays the contents of the report object. You can find that the subsetted data has been returned. based on the condition that is marks greater than 60. We can also have complex subset expressions. For example, let us consider marks greater than 60 and, which is a logical operator, id less than 103. Let us execute these statements. We will first display the contents of the data frame students, and then we will execute the subset function and display the data frame returned by the subset function. You can find that only one row is returned that satisfies the subset condition, that is marks greater than 60 and id less than 103. The third argument of the subset function is select, which is used to select columns from the data frame. If the select argument is not provided, then by default all the columns or attributes of the data frame are selected. Let us consider that we have the subset expression that is marks greater than 60, comma, the third argument we will use as select, followed by assignment symbol, and then the C function. Within the C function, we will provide the name of the attribute we are selecting. In this case, let us consider that we are selecting the attribute name. Let us execute the statement. You can find that we have the result as names displayed, which satisfies the subset expression, that is marks greater than 60. In the same way, suppose if we have to select multiple columns, then within the C function we can provide multiple attributes. For example, let us select name and marks. So we will have name, comma, marks. Let us execute the statement. You can find that we have the result as the elements of the names and marks column, which satisfies the subset expression, that is marks greater than 60. In the same way, instead of using the C function for the select attribute, we can also use the sequence operator. That is, we can have name colon marks. Let us execute the statement. You can find that we get the same result. We can also use negative indexes or negative column names for the select argument. Suppose if I want only id and marks column to be displayed, I can use select followed by equal to symbol, then minus name. When we execute the statement, you can find that except the name column, elements of the other column is displayed, which satisfies the subset condition. So this is how we can use subset function on data frames to get the result based on the expression provided in the second attribute. In this video, we will look at how to append rows and columns to the existing data frame using the rbind and cbind functions. Let us create a data frame for using rbind and cbind functions. Let us consider that we are creating data frames using three attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame, and then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name and marks. Let us now display the data frame, that is students. Let us execute these statements, and finally we will print the data frame, that is students. Let us again use the students object, and with the assignment operator we will use the rbind function. The first argument of the rbind function is the data frame to which we will be appending a row. In this case it is students. The second argument is the row which we will append to the existing data frame. So we will create the row using data.frame function. Within the data.frame function, we will have the column name, that is in this case ID, and using the equal to symbol, we will assign the value to the ID. That is, let us consider as the ID is 104. The second column is the name, so we will use name and assign the value as, let's say, Jack. and the third column is marks. So we will use marks and we will assign the value as 45.85. Let us again display the student's data frame. We will execute the statement before the rbind function, which gives us the original data frame. The next statement uses the rbind function, which will append a row to the existing data frame. We will again display the contents of the student's data frame. You can observe that new row is appended to the existing data frame. Let us look at how to use cbind function. Even for the cbind function, we will use the students object. So therefore, we will have students and then use the assignment operator followed by the cbind function. The first argument of the cbind function is the object to which we are binding the column. So therefore we will have students object as the first argument followed by the second argument. In the second argument we need to give the name for the column. Let us give the name as age, and using the assignment statement with the C function we will create an age object. Within the C function, we will provide 3 elements for the age column. Let us have the first element as 18 and the second element as, let's say, 24 and the third element as, let's say, 19. We will again print the student's data frame. Let us display the contents of the student's data frame before using the column bind operation. Let us display the contents of the student's data frame. We will execute the next statement, which uses cbind function. We will again display the student's data frame after using the cbind function. You can observe that a new column or attribute with age is created. The second argument of the cbind function is a vector. This vector should have the same number of elements, that is, the length of this vector should be equal to the number of rows. So this is how rbind and cbind functions can be used to append row or a column to the existing data frame. In this video, we will look at how to display the data from the data frames in a tabular window. R programming language provides an edit function which works for data frames containing numeric, logical, and character vectors. To demonstrate the working of edit function in data frames, let us first create a data frame. Let us consider that we are creating data frames using 3 attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame. And then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name, and marks. Let us now display the data frame, that is students. Let us execute these statements. And finally, we will print the data frame, that is students. Let us now create an object with the name as students table, and we will use the assignment operator with the edit function. The first argument in the edit function is the data frame. We will provide students as the first argument. The other arguments are optional, that is factor.mode, through which we can specify how to handle factors. The third argument uses logical values to display the row names. In the next statement, we will display the contents of the data frame, that is students table. Let us display the contents of the students data frame. We will execute the next statement, which uses the edit function. You can find that a window is displayed which consists of data in a tabular fashion. We can also update the values within the tabular window. For example, let us change the value in the third row of the marks column and let us give the value as 85.25. We can close the window, and after closing the window, and when we display the contents of the students table data frame, you can find that we have the updated value. But remember that the value of the student data frame is not altered. So this is how we can use the edit function on data frames. In this video, we will look at how to handle missing values in vectors or data frames in R programming language. The missing values are denoted by NA. NA in R programming language stands for not available, or NaN, which stands for not a number, for undefined mathematical operations. Let us create a vector x using the assignment operator and function c. Let us consider that we have the elements of vector as 10, 4, NA, 7 and 15. Let us print the elements of vector x. When we execute these statements, you can find that vector x is created which has a missing value represented by NA. We can use a function is.na which is used to test the objects, that is in this case vectors or data frames, if they have missing values. So in this case we can use is.na and we will pass x as the argument, which is a vector. When we execute the statement, you can find that we have logical values displayed. That is, for the first two elements 10 and 4, we have the logical values displayed as false. For the third element, that is NA, we have the logical value true is displayed, and for the next two elements, that is 7 and 15, we have the logical value as false displayed. We can also use s.nan function, which is used to test whether an object contains nan values. When we execute the statement, you can find that we have a logical vector as a result with all the elements as false, because none of the elements contains nan value. The na values have a class, so we can have integer na, character na, and so on. But whereas nan values do not have a class. So therefore, even though we have the third element as na, we get the logical value as false, since na values are not nan values. Let us consider that the last element of the vector x is a nan value. When we execute the third statement, that is is.na function, you can find that we get the result as a logical vector where the third element is true as well as the fifth element is true. When we execute the fourth statement, that is is.nan function, we get the logical vector where only the last element is true. Now let us consider that we have a vector x with two missing values. That is, the third element is NA as well as the fifth element is NA. When we execute these statements, you can find that we get the result as a logical vector where third element and fifth element is true. A common task in data analysis is to remove missing values from a data set. So in this case, to remove the missing values from a vector x, we will assign the value returned by is.na function, which is a logical vector, to a vector y. We will then display the data stored in vector y. When we execute these statements, you can find that the logical values returned by is.na function is stored in vector y. In the next statement, we will subset the elements of vector x using the logical vector y. So we will have x in square brackets not of y. When we are using not operator, which is a negation operator, on vector y, which is a logical vector, all the false values are negated to true and true values are negated to false, since we need to remove the missing values. When we execute the statement, you can find that we have the result as a vector which contains the first two elements and the fourth element, and all the missing values, that is NA, are removed. Let us now consider how to remove missing values from data frames in R programming language. We will create a vector ID, and using the assignment operator and C function, we will have the elements as 101, 102, 103, 104 and 105. We will create another vector, let us consider as temperature, and using the assignment operator and C function, we will have the elements as 25.8, 34.2, and the third element, let us consider that we have a missing value, that is NA, the fourth element as 27.4 and the fifth element as 20.5. we will consider another vector, that is wind, and using the assignment operator and C function, we will have the values as 78, 59, 63, 40, and 68. We will consider another vector, that is in this case humidity, and using the assignment operator and C function, we will have the elements as 25, 45, 85, and the fourth element as NA, which is a missing value, and fifth element as 61. Let us now create a data frame with the name as weather using these four vectors. So we will have the object as weather, followed by assignment operator and data.frame function. And within the data.frame function, we will pass the first argument as a vector ID, the second argument as vector temperature, the third argument as vector wind, and fourth argument as vector humidity. So now we have created a data frame with the name as weather, which stores the information regarding weather, that is temperature, wind, and humidity, and this data frame has some missing values. In the next statement, we will display the contents of the data frame, that is weather. Let us execute these statements. The first statement will create a vector, which is ID. The second statement will create a vector, that is temperature. The third statement will create a vector, that is wind. The fourth statement will create a vector, that is humidity. And the fifth statement will create a data frame. And subsequently, we are displaying the contents of the data frame. You can find that the contents of the data frame, that is on the third row, we have a missing value, as well as on the fourth row, also we have a missing value. So now we have two rows, that is row with ID 103 and 104, which has missing values. Our programming language provides a function known as complete.cases, which is used to remove missing values from more than one object. That is, in this case, we have a missing value in an object temperature, which is a vector, as well as we also have a missing value in object humidity, which is also a vector. So we will create another object, that is, let us call it as weather NA, and using the assignment operator and complete.cases function, we will pass the argument as the data frame, which is vector, to complete.cases function. Let us print the contents of the object, that is weather NA. When we execute these statements, you can find that we get a logical vector, where the third and the fourth element is false, since we have missing values in third and fourth row of the data frame. The first element of the logical vector is true because in the first row of the data frame there are no missing values. Even the second element of the vector is true since the second row doesn't have any missing values. The third element of the vector is false since the third row of the data frame has a missing value, as well as the fourth element of the vector is also false since in the fourth row of the data frame also we have a missing value. The fifth element of the vector is true since the fifth row of the data frame does not contain any missing values. Now, to display a data frame without any missing values, we can use the object, that is in this case weather, and within square brackets we will pass the logical vector, that is weather NA, followed by comma, since we need to retrieve all the rows which do not have any missing values. When we execute this statement, you can find that we have the result as a data frame which contains only first, second, and fifth row, and none of the elements of the data frame has missing values. So this is how, using the is.na function as well as using complete.cases function, we can remove the missing values from vectors or data frames. In this video, we will look at how to import data from text files. Our programming language provides read.tables function, which is most commonly used function for reading data. The read.table function has some important arguments. The first argument is the file, through which we can specify the name of the file from which we are reading the data. And this is the mandatory argument. The next argument is the header, which uses logical value indicating if the file has header. The default value of this argument is false. The third argument is SCP, which stands for separator. It uses a string value indicating how columns are separated. By default, space is used as a separator. Another argument is nRows, through which we can specify the number of rows to read in a dataset. By default, the function reads an entire file. And we also have a skip argument, through which we can specify the number of lines to skip from the beginning. The default value of this argument is 0. If the lines in the data file which we are reading has a hash at the beginning of the line, then the function skips reading those lines. Let us consider a text file. Here I have data.txt as the text file. This file contains some data separated by spaces. Let us write the statements to read the data from this data file into our R program. We will create an object as myData, followed by the assignment operator, and then we will use the read.table function. Within the read.table function, we will provide the file name. That is, in this case, it is data.txt. File names are always provided within single or double quotes. In the next statement, we will display the contents of the myData object. Let us execute these statements. The first statement reads the entire content from the data file, that is data.txt, and stores it in myData object. When we execute the statement, you can find that the entire data read from the data.txt file is now stored in the object which is referred as myData. In this function, we are directly providing the file name. If the data.txt file is in the current working directory, then we can directly use the file name. Else you need to provide the absolute path where the data file is stored. In the read.table function, since we are not using the header argument, you can observe that our programming language has implicitly provided its own names for the columns. Let us use the header argument and assign the value as true. Let us execute these statements. You can now find that the read.table function has now considered the first line of the data file as the header, which represents the columns. Let us look at the nRows attribute. For example, we will assign the value to the nRows argument as 5, which means that we want to read the first 5 lines from the data file. Let us execute these statements. You can find that only first 5 lines has been read. Since we are using the header argument, the first line of the data file is considered as the column names, and next 5 lines are read. In the same way, we can use the skip argument. Let us use skip and assign the value as 3. We will execute these statements. You can find that the read.table function has skipped the first 3 lines, and the next line is considered as the header for the column names, and the rest of the lines are read. Let us consider another data file. That is, I have a data file with the name as data$.txt. This file contains $ as the separator for the values. Let us now consider a scenario of reading the data$.txt file. Let us execute these statements. You can find that the entire data has been read as a single column. This is because we are using $ as a separator, and by default read.table function uses space as the separator. So in this case, we can use SCP as the argument and assign the value as $. Let us now execute these statements. Now you can find that the data has been read according to the separator, that is in this case $. So therefore we can read any text data file, but we need to consider how data is separated and then assign that character to the SCP argument. So this is how we can import data from the text files using the read.tables function. In this video, we will look at how to import data from the CSV or comma separated value files. To read data from CSV or comma separated values file, R provides the read.csv function, which is much similar to the read.tables function, except that some of the defaults are set separately, like the SCP argument. In the read.tables function, the default value for the SCP argument is space, whereas in read.csv function, the default value for SCP argument is a comma. Let us consider that we have a comma separated file, that is in this case we have sample.csv. We can select this file from the File Explorer window and then we can click View File. You can find that the entire data of the file is separated by comma. Let us write our program to import comma separated data. We will use an object as myData followed by the assignment operator. We will then use read.csv function. The first argument of the CSV function is the file name. In this case, the file name is sample.csv. So we will use a single quote and then provide the file name, that is sample.csv. In the next statement, we will print the contents of the myData object. Let us execute these statements. The first statement uses read.csv function, which reads the entire content of the comma-separated values file. And when we execute the next statement, we have the entire data of the comma-separated file, that is in this case sample.csv file is displayed. Here you can observe that even the header argument by default is true when compared to the read.table function, where we need to explicitly provide the header argument as true. So this is how we can use read.csv function to import the data from the comma-separated value files. In this video, we will look at how to import data from RDS files into a data frame. R programming language has its own binary format. Using this R's binary format, it is very fast and efficient to write and load data for big or large data applications. But there is a drawback in using this format because the data from this format cannot be used in other programs. The data files created using R's binary format has an extension as .rds. To import data from RDS files, let us create an object myData, and using the assignment statement, we can use the function readRDS. Remember that the characters RDS in the function are in capital case. The first argument of the RDS function will be the file name. That is, let us consider that in this case we have chicago.rds as the file. In the next statement, we will print the contents of the data frame, that is myData. When we execute these statements, you can find that the entire content of the chicago.rds file is imported into a data frame, that is myData. So this is how, using the readRDS function, we can import the data from RDS files. In this video, we will look at how to import data from the files which are stored on internet. To import or load data from the internet, we need to follow 3 steps. The first step is to check the presence of the data on the internet, since the data is not on the local disk. Therefore, the first statement we will use is url.show function. The first argument of the show function is the URL, where the data is located. So in this case, we will have the URL as http:// followed by the name of the website, that is in this case softlict.in/datasets/sbugsprices.csv. The extension .csv stands for comma-separated value files. When we execute the statement, you can find that the entire content of the CSV file is displayed. The second step is to check the structure of the dataset. That is, you can find that this dataset contains several rows. The first row contains the header, and all the elements or values are separated through comma. The third step will be to use the read.table function to retrieve the contents from the URL and store it in a data frame. So we will have an object as myData followed by the assignment operator and read.table function. The first argument of the table function will not be a file name, but it will be a URL. The second parameter or the argument we will pass is a separator. In this case, we have the separator as comma, and the third argument we will pass is the head as true. In the subsequent statement, we will display the contents of the data frame, that is myData. Let us execute these statements. You can find that the content from the URL is stored in a data frame, that is in this case myData. So this is how we can use read.table function, passing the URL as the argument to retrieve the data or import the data from the internet or remote location. In this video, we will look at how to import data from the clipboard. On Windows operating system or Mac operating system, you can select the data and copy it to a clipboard. In Windows operating system, you can use Ctrl+C to copy the data into a clipboard. We will create an object as myData, followed by the assignment operator and read.table function. The first argument of the table function will be a string clipboard within single quotes. In the next statement, we will display the contents of the data frame, that is myData in this case. Let us open a file and select the contents, and using Ctrl+C, let us copy the contents to a clipboard. We will execute the statements of the R script. You can find that the entire data copied to the clipboard is stored in the data frame and displayed as the result. If you observe the data, the first row of the data contains the headers. But whereas when we have imported the data from the clipboard, default names are assigned as headers to the columns. And header from the text file is considered as the first row of the data frame. To specify that the clipboard contains first row as the header, we can use the parameter as head equal to true. When we execute these statements, you can now find that the first row of the clipboard is considered as the header for column names. Let us copy the contents of another file where the elements are now separated by comma. We will copy the contents of this file into a clipboard using Ctrl+C. Let us once more execute the statements in our script. You can find that the entire content of the clipboard is stored in a data frame. But when we display the contents of the data frame, you can observe that the entire data is imported in a single column. Since the elements are separated by comma, we can use SCP as an argument, which is assigned a value, comma as a string. Let us execute these statements. You can now find that the entire content is imported into a data frame with all the columns and rows. So this is how we can use read.tables function to import the data from the clipboard. In this video, we will look at how to export data to the comma-separated values or CSV files. R provides a function write.csv through which we can export the contents of the data frame to a file. To demonstrate the working of the write.csv function, let us first create a data frame. Let us consider that we are creating data frames using three attributes. That is, first attribute is the ID. So we will create a vector for the ID. Let us use an ID as an object, and using the assignment operator and the C function, let us create elements of the vector ID. Let us have the elements as 101, 102 and 103. We will use another attribute, that is name. Let us create a vector for name attribute, and using the assignment operator and C function, we will create the elements for the vector name. Let us have the first element as Bob, the second element as Alice, and the third element as John. Let us consider the third attribute as marks. We will create a vector for marks using the assignment operator and C function. And let us have the elements of the marks vector as 78.25, 59.45 and 63.85. Please remember that when we are creating data frames, the length of all the vectors, that is in this case ID, name and marks, which are treated as attributes, must be same. Let us now create a data frame with the object as students. We will use an assignment operator, then we will use the function data.frame, and then we will pass vectors as the arguments, which denotes the attributes of the data frame. In this case, we have the attributes or vectors as ID, name and marks. Let us now display the data frame, that is students. Let us execute these statements. And finally, we will print the data frame, that is students. We will now use write.csv function. The first argument of the write.csv function is the data frame object. That is, in this case, we have students as the data frame object. The next argument is the file name. to which we export the contents of the data frame. So we will have second argument as file, followed by the equal to symbol, and then the file name. Let us provide the file name as output.csv. When we execute these statements, you can find that the write.csv function will create a file in the current working directory with the name as output.csv. We can view the contents of this file by clicking on the file name and then selecting View File. You can find that the entire data of the student's data frame is exported to the output.csv file. So this is how we can use write.csv function to export the contents of the data frame to the CSV file. In this video, we will talk about dplyr package, which provides intuitive functionality for working with data tables. The data frame is an important data structure in R for statistics. The basic structure of data frame is that they are observations per row, and each column represents a variable or a measure or characteristic of the observation. Once we start more advanced data analysis, we will be manipulating data frames or data tables. For this purpose, we need to use dplyr package, which provides intuitive functionality for working with data tables. The dplyr package is designed to mitigate a lot of problems and to provide a highly optimized set of functions specially dealing with data frames. The dplyr package does not provide any new functionality to R programming language. It only simplifies existing functionality in R. The dplyr functions are very fast compared to the usual functions provided for data frames. This package has functions that perform the most common operations for data manipulation, and the names of these functions are relatively easy to remember. To use dplyr package in R programming language, we need to first install the dplyr package. To install dplyr package, we need to use the statement install.packages in the console window. For example, in the console window, we will use install.packages function, and within single quotes, we will type dplyr. Here the argument for the packages function is the package name. Once you hit enter, the install.packages function or the command will download the dplyr package along with all the dependent packages and install them. Once the command is successful, the execution ends and the cursor is back to the console prompt. After the package is installed in the execution environment, it is important to load the package with the library function. For example, library, and within the parentheses, we will provide the package name, that is dplyr. Note that for the library function, we do not need to use dplyr in single or double quotes. So this is how dplyr package or any other package can be installed in our programming environment. In this video, we will look at select function of the dplyr package. The select function from the dplyr package is used to subset the data by selecting specific columns. Let us load the dplyr package using the library function. For example, library, in parentheses, we will provide dplyr. In the next statement, we will create an object, myData, and using the assignment operator and the read.csv function, we will read the contents of murders.csv file. The murders.csv file is a comma-separated file which contains data about murders, populations, with other variables in each state. So inside the parentheses of the CSV function, within quotes, we will provide the file name as murders.csv. In the next statement, we will print the contents of the myData object. Let us execute this program. The first statement will load the dplyr library. The second statement will read the contents from the murders.csv file. And the third statement will display the contents of the data frame, that is in this case myData. We will now use the dim function which will retrieve the dimensions of the object. For example, we can use dim and within parentheses pass the object, that is in this case myData. Let us execute the statement. You can find that we have the dimensions as 51 and 8, where the value 51 represents the number of observations and the value 8 represents the number of columns or measures or variables. We can also use the str function For example, str of MyData will display the structure of the MyData object. For example, it displays how many observations we have and number of variables or columns, as well as the names of the columns that are used in the data frame with their types. For example, state column is represented as a factor, ABB column is also represented as a factor, whereas the values of the population column are represented as integers, and the values of population density is represented as numbers, and so on. The select function can be used to select columns of a data frame. Often we have large data set containing many columns, but for analysis we might only need a few columns or variables or observations. Although our data table only has 8 columns, some data tables include hundreds. So it's often useful to select just the columns that we want to work with. The select function is used in such situations. Before we look at the select function, let us look at the normal way of subsetting the columns of the data frame. We can use the object that is MyData, and within square brackets, using the C function, we can pass the indexes of the columns. For example, in this case, we will have 1, 4, 6. Let us execute the statement. You can find that we have the result as all the observations along with only first, fourth and sixth columns. Using the column indexes in the C function is not very helpful. So therefore, let us try to use the column names. For example, we will use within the C function state as a column name, comma, population as the column name, comma, and the third argument, that is murders, as a column name. When we execute the statement, we get an error, since the names of the columns cannot be used within the C function for data frames. Using the select function will be much more helpful, where we can use the column names to access the selected columns. Let us look at another function, names. This function will take object as an argument. In this case, we will provide MyData. Let us execute the statement. You can find that the names function will return the names of the columns of the object. That is, in this case, the names of the columns of MyData object. We will now look at the working of the select function. Let us create an object, MySubData, followed by the assignment operator, and then we will use the select function. The first argument of the select function is the data frame. In this case, we will pass MyData. The second argument we will provide is the sequence of columns. For example, we will use state, population. When we execute the statement, all the observations or rows from the data frame MyData will be selected as per the column range from state to population, and the result is stored in MySubData object, which is also a data frame. In the next statement, we will print the contents of MySubData. Let us execute the statement. You can find that all the observations with the column state, ABB, region and population are displayed. We can also provide individual columns to be selected in the select function. For example, we can use select MyData, which is a data frame, comma, the first column as state, the second column as population, the third column as murders, and the fourth column, for example, gun murders. Let us execute these statements. You can find that we have the output as all the observations with the columns of state, population, murders, and gun murders. We can also omit columns using the negative sign with the select function. For example, if I want all the columns to be selected except ABB, then in the second argument I will pass -ABB. When we execute these statements, you can find that all the columns are selected except ABB. We can also use a colon operator to omit sequence of columns. For example, we can have minus or the negative sign, and within parentheses, let us use ABB : region. When we execute these statements, you can find that all the columns are selected except columns from ABB to region. Suppose if we want to eliminate arbitrary number of columns using the select function, we can use a negative sign with the C function, and within the C function, we will pass the arguments as the columns to be eliminated. For example, in this case, let us use ABB, region, population, gun ownership. When we execute these statements, you can find that all the columns are selected except the columns which are mentioned inside the C function with the negative sign. So this is how we can use the select function of dplyr package to select columns that we want to work with. In this video, we will look at how filter function of dplyr package works. Let us use the library function and load the dplyr package. In the next statement, we will create an object myData, and using the assignment operator and read.csv function, we will import the contents of murders.csv file. In the next statement, we will display the column names using the names function and passing myData as the argument. Let us execute these statements. You can find that names of all the columns are displayed. We will now create another object, that is mySubData, and through the assignment operator we will use the filter function. The first argument of the filter function is the data frame itself, that is in this case myData. The second argument is the filter's condition. For example, suppose if we want to find the states in which murders are more than 100. So we will use the condition as murders greater than 100. In the next statement, we will display the contents of the object mySubData. Let us execute these statements. You can find that we have the output as 32 observations, which satisfies the condition that murders greater than 100. Now here the filter function returns the number of observations that meets the condition. That is, in this case, murders greater than 100. But suppose if I want to show only few columns, then we can use the select function. For example, let us create another object, that is mySubData murders, and with the assignment operator we will use the select function. In the select function we will pass mySubData as the data frame for the first argument, and we will only select state and murders as the columns. The next statement, we will display the contents of mySubData murders object. Let us execute the statement. You can find that we have the display with only two columns, that is state and murders, which satisfy the condition murders greater than 100. Suppose if I also want to display the population column along with the states and murders. So in the select function, we can also have population as the name of the column as an argument. When we execute these statements, you can find that we have the result displayed with states, population, and murders columns. In filter function, we can also have complex conditions or expressions. For example, suppose if I want the result as where murders are greater than 100 as well as population less than 10 million. So within the filter function, in the second argument, I can have murders greater than 100, and then we can use the logical operator AND, that is the AND symbol, and the other condition, that is population less than 10 million. When we execute these statements, you can find that 25 observations has been displayed with the state, population, and murders columns. So this is how we can use the filter function of the dplyr package to return the rows based on the condition provided in the filter function. In this video, we will look at the working of the arrange function of the dplyr package. The arrange function is used to reorder rows of a data frame according to one of the columns. Let us use the library function to load the dplyr package. In the next statement, we will create an object, that is myData, and with the assignment operator and read.csv function, we will import the data from the murders.csv file. The next statement, we will use names of myData, which provides the names of the columns of myData object. Let us execute these statements. We have the display of all the columns of the myData object. Let us create another object, mySubData. And with the assignment operator, we will use the arrange function. The first argument of the arrange function is the data frame, and the second argument is the column name. Let us use the column names as murders. In the next statement, we will display the contents of mySubData object. Let us execute these statements. You can find that all the observations with the columns are displayed, which are arranged in ascending order according to the column murders. Let us use a select function to select only the columns which we need. For example, we will create another object that is mySubDataMurders, and with the assignment statement, we will use the select function. The first argument of the select function will be mySubData, and the second and the third argument we will pass states, murders. In the next statement, we will display the contents of mySubDataMurders object. When we execute these statements, you can find that all the observations or rows with states and murders are displayed. If you observe, since we have used the arrange function, the observations are displayed in the ascending order according to murders. R programming language also provides head and tail functions to look at the first and the last rows according to some specified values. For example, we can use head function, and within parentheses, the first argument will be the data frame. That is, in this case, it is mySubDataMurders. And the next argument, we will provide the value that is 5. When we execute the statement, you can find that first 5 rows or observations are returned. In the same way, we can have the tail function. The first argument of the tail function will also be a data frame, that is, in this case, it is mySubDataMurders. And the next argument, let us pass the value as 5. When we execute this statement, you can find that the last 5 rows or observations of the data frame mySubDataMurders are returned. By default, the second argument of the arrange function will sort the rows in ascending order according to the column name specified. We can use the DESC function, which stands for decreasing, inside the arrange function with the column name to sort the rows in descending order. For example, we will use the second argument of the arrange function as DESC, and within parentheses we will pass murders as the column name. Let us execute these statements. You can find that all the observations or rows are displayed with state and murders as the columns. Let us also display the population column using the select function. When we execute the statement with the head function, you can find that the top 5 states with most murders are displayed along with the states, population and murders columns. In this video, we will look at how rename function of the dplyr package works. Let us load the dplyr package using the library function. The next statement, we will create an object myData. With the assignment operator, we will use the read.csv function and import the contents of murders.csv file. In the next statement, we will display the names of the columns of myData data frame using the names function. Let us execute these 3 statements. You can find that we have the result displayed as names of the columns. Let us use the same object myData. With the assignment operator, we will use the rename function. The first argument of the rename function is the data frame. That is, in this case, it is myData. The column names in the dataset or data frame may be very confusing at times. The rename function is used to rename column names to have more sensible meaning. So the second argument of the rename function, we will use abbreviation equal to ABB. The left hand side of the equal to sign represents the new name for the column, and the right hand side is the old name of the column. The next statement, we will again use names function, that is names of myData. We will create another object that is mySubData, and with the assignment operator, we will use the select function. The first argument we will pass is myData, and the next argument we will pass is the state, which is a column name, comma abbreviation, which is the new column name which we have assigned to ABB. And then we will also select the murders column. In the next statement, we will display the contents of mySubData object. When we execute these statements, you can find that the rename function has renamed the ABB column to abbreviation. This is evident when we use the names of myData function. You can find that ABB, which is the previous column name, has been changed to abbreviation, which is now the renamed column name. When we execute the subsequent statement, that is, which uses the select function, you can find that with the other column names we are using the renamed column name, that is abbreviation, and the result is displayed according to the renamed column. We can also rename multiple columns using the rename function. For example, let us consider that we also want to rename the murders column as homicide. So we will use homicide followed by the equal to sign and the old column name, that is murders. Let us execute these statements. You can find that two columns have been renamed, that is ABB and murders are renamed with abbreviation and homicide. Let us execute the next statement. You can find that we get an error. This is because although we are using abbreviation as the renamed column, but we are also using murders in the select function. In the earlier statement with the rename function, the murders column was renamed as homicide, and therefore we need to now use the new column name. That is, instead of murders, we should use homicide. And when we execute these statements, we do not have any error, and the result is displayed with states, abbreviations, and homicide columns. So this is how rename function of the dplyr package works. In this video, we will look at how the mutate function of the dplyr package works. The mutate function is used to change the data table by adding a new column or changing an existing one. Using the mutate function, we can create new columns that are derived from existing columns. Let us import the dplyr package using the library function. In the next statement, we will create an object myData followed by the assignment symbol and read.csv function. We will import the data from the murders.csv file. In the next statement, we will use the names function and pass myData as the argument. When we execute these statements, you can find that all the column names of myData data frame is retrieved. We will use an object mySubData followed by the assignment symbol and mutate function. The first argument of the mutate function is the data frame, that is in this case myData. The second argument will be the newly created column. That is, in this case, let us create a column ratio, and using the assignment statement, we will compute the ratio between murders to the population. Let us again use the names function and pass the argument as mySubData. Let us execute these statements. You can find that we have a new column as a ratio in the mySubData data frame. We will create another object mySubData ratio. Using the assignment operator and the select function, we will pass the first argument as mySubData, that is the data frame, and we will select the columns as state, population, murders, and ratio. Ratio is the newly created column using the mutate function. In the next statement, we will print the contents of the mySubData ratio object. When we execute these statements, you can find that we have the table displayed with the state, population, murders, and ratio as the columns. R programming language also provides transmute function, which does the same thing as mutate but drops all the non-transformed columns. Let us create an object mySubData followed by the assignment operator and then transmute function. The first argument of the transmute function is the data frame, that is in this case myData. The second argument is the newly formed column, that is in this case we will use ratio. With the assignment operator, we will compute murders divided by population. In the next statement, we will print the contents of mySubData object. When we execute these statements, you can find that the table with only ratio as the column is displayed. This is because transmute function has dropped all the non-transformed columns. This is evident when we use the names function and pass mySubData as the argument. When we execute this statement, you can find that the data frame, that is mySubData, contains only one column, that is ratio. To include other columns, such as for example, I want to include states column as well. So I can use state equal to state, which means that I am also transforming the states column. When we execute this statement, you can find that we have the table displayed with state as well as ratio column. So this is how mutate function of the dplyr package can be used. In this video, we will look at groupby function of the dplyr package, which is used to generate summary statistics. Let us use the library function to load the dplyr package. The next statement, we will create an object as myData, and using the assignment operator and read.csv function, we will import the contents of murders.csv file. We will use the names function, that is names of myData, and execute these statements. You can find that we have all the columns of myData data frame displayed. In the next statement, we will display the contents of myData object, that is a data frame. When we execute the statement, you can find that we have a column as region, and this is the column we will be using in the groupby function. Let us create an object mySubData, and using the assignment operator, we will have the groupby function. The first argument of the groupby function is the data frame, that is in this case myData. The second argument, that is in this case we will have region. In the next statement, let us print the contents of mySubData object. When we execute these statements, you can find that groups of 4 regions have been created from 51 observations and 8 columns. The dplyr package provides a summarize function, which is used in conjunction with the groupby function to get the summary of the data frame. Let us use summarize function. The first argument of the summarize function is the data frame, which is generated as a subset using the groupby function, and the second argument itself is a function which is applied on the columns of the data frame. In this case, we will use sum as the function, and within parentheses we will have the column as murders. Let us execute this statement. You can find that we have the table displayed with the region as well as the sum as the column. We can also use mean as the function, and let us execute the statement. You can find that the means of the murders have been calculated for regions. We can also use max function, and when we execute the statement, you can find that the maximum value within the group as the region is computed. We can also use median function, which computes the median for the murders within the group, in this case it's region. So this is how the groupby function of the dplyr package can be used in conjunction with the summarize function to get the statistics about a data frame. In this video, we will look at the pipeline operator, which is very handy for applying sequence of operations on data frames. Let us load the dplyr library using the library function. In the next statement, we will create an object myData using the assignment operator and read.csv function, through which we will import the contents from murders.csv file. In the next statement, we will use a names function of myData object. When we execute these statements, you can find that the column names of myData object has been retrieved. We can perform series of operations, for example, selecting this and filtering that by passing the result of one function to another function. For example, let us create an object mySubData, and using the assignment operator with the arrange function, we will pass the first argument as the data frame. In this case, it is myData, and the second argument as murders. So in this statement, we are actually sorting the data frame according to the murders column in ascending order. In the next statement, we will create an object mySubData murders. With the assignment operator and select function, we will pass the first argument as mySubData, and we will select the columns as state and murders. In the next statement, we will print the contents of mySubData murders object. Let us execute these statements. You can find that we have a table displayed with state and murders as the columns. Now here we have used two different statements for performing two different operations. That is arrange operation using the arrange function and selecting the columns using the select function. The pipeline operator can be used to pass the result of one function to another function. The pipeline operator works on sequence of operations from left to right. Let us use the pipeline operator. So we will use a function arrange and pass the first argument as myData, which is a data frame, and then we will pass the second argument as murders, followed by the pipeline operator, that is percentage, greater than symbol, and percentage. Then we will use another function, that is in this case select, to select the columns of state and murders. So we will have the select function, and the first parameter we will pass is the state, and the second parameter we will pass is the murders. Notice here that we are not passing the first parameter as a data frame. The pipeline operator works on sequence of operations from left to right. In the pipeline operator, the result of the first operation is the input for the second operation. That is, the result of the first operation is treated as the first argument of the second operation. In this case, we have the first operation as the arrange function. The result of this arrange function is the input to the subsequent operation, that is in this case select function. Therefore, we should not provide data frame as the first argument for the subsequent operation, though we need to provide the data frame as the first argument for the first operation, that is in this case it is the arrange function. When we execute these statements, you can find that we get the same result. In the same statement which uses the pipeline operator, we can also use DESC function to arrange the murders column according to descending order. When we execute the statement, you can find that we have the table displayed with states and murders as the column, where the values of the table are sorted in descending order. Let us take another scenario that I want to retrieve top 3 states with highest murders. Since we have already used the arrange function and arranged the states according to the murders in descending order, as well as we have also used the second operation, that is selected the states and murders, we will use another pipeline operator and use the head function, that is the head function, and we will pass the argument as 3. Note that even here we need not provide the first argument as the data frame, since the result of the select function is the input for the head function. When we execute the statement, you can find that we have a table displayed which contains top 3 states with highest murders. So this is how we can use the pipe operator or pipeline operator, which is very handy for applying sequence of operations on data frames. In this video, we will learn about data visualization in R programming language. Data visualization is perhaps the main strength of R programming language. We can plot or visualize data flexibly and with ease in R programming language. We will look at how to create bar plots in R programming language. To demonstrate plots or data visualization, we will be using the population and murders data in different states. Let us begin by loading the dplyr package. We will use the library function, and within parentheses we will pass dplyr. In the next statement, we will create an object myData. With the assignment operator and read.csv function, we will import the data from murders.csv file. The murders.csv file contains many columns, but to demonstrate plots, we would only use states, population, and murders. So let us create an object mySubData. We will use the assignment operator with the select function, and the first argument for the select function will be the data frame, that is myData. The other arguments are the columns which we want to select. For example, we will use state, population, and murders. To create a bar graph, we need to use the bar plot function, which plots vertical or horizontal bars. So let us use bar plot function. The argument for the bar plot function is a numerical vector. So let us use mySubData, and with the dollar symbol, we will pass the values for the population. Let us execute these statements. The first statement will load the dplyr library. The second statement will import data from murders.csv file. The third statement uses a select function from the dplyr library, where we are selecting 3 columns, that is state, population, and murders. The subsequent statement will plot the bar graph. When we execute the statement, you can find that the bar graph is plotted. We can click the zoom button to view the zoomed bar graph. You can find that this is the very basic bar graph created. We can use the other parameters or arguments of the bar plot function to change the look and feel for the bar graph. Let us provide the labels for the x-axis. That is, we can use the parameter xlab, and let us assign the x-axis as states. In the same way, we will use ylab to assign the label for the y-axis, that is in this case, let's say population. We can also give the title for the bar graph. That is, we can use the parameter main, and let us assign the label as states versus population. We can provide the labels for each bar using the names.arg parameter. Here we will assign the values of the states. So we will use mySubData with the dollar symbol state. We can also change the color for the bars using the col parameter. Let us assign the value as blue. Let us again execute the statement. you can find that we have the title for the bar graph, that is states versus population. We also have the label for x-axis as well as y-axis, that is states and population. Let us look at another scenario of plotting murders. Instead of passing the values for the population vector, we will pass the values for the murders vector. So we will use my subdata followed by the dollar symbol, and then we will use murders column. We will change the label for the y-axis, that is in this case we will have murders, as well as we will change the title of the graph, that is states versus, instead of population we will have murders. Let us execute the statement. You can find that now the graph is plotted for the values of murders in different states. Let us look at another scenario, that is we will plot the graph for top 5 states with highest murders. We will use an object mySubdataSort. Using the assignment operator and arrange function, the first argument we will pass is myData, which is a data frame. For the second argument, we will use a DESC function and sort the data frame according to murders column. In the next statement, we will use the select function, and the first argument we will have as mySubdataSort. We will create another object, that is myHighData. Using the assignment operator and head function, we will pass the first argument as mySubdata and the second argument as value 5, since we need top 5 states with highest murders. And in the next statement, that is bar plot, instead of using mySubdata, we will use myHighData. As well as in names.arg argument, we will use myHighData as the object. Let us execute these statements. You can find that the bar graph is plotted with states and murders. Here we have only the top 5 states with highest murders. So you can find that the California is having the highest murders, followed by Texas, and so on. So this is how we can use the bar plot function to generate bar graphs. In this video, let us look at how to plot horizontal bar plots. Let us begin by loading the dplyr package. We will use the library function, and within parentheses we will pass dplyr. In the next statement, we will create an object myData, and with the assignment operator and read.csv function, we will import data from murdersmini.csv file. This CSV file contains the data of states, population, and murders. In the next statement, we will create an object myCellData. Using the assignment operator and select function, we will pass the first argument as myData and the second argument as state and third argument as murders. We will create the bar graph using the bar plot function. The first argument we will pass is mySELData, followed by the dollar symbol and murders column. When we execute these statements, you can find that a bar graph is plotted vertically. We can use the Horace parameter and assign the value as true. When we execute this statement, you can find that the bar graph is now plotted horizontally. We can also change the look and feel of the bar plot using the other parameters. That is, in this case, let us use xlab for labeling the x-axis and assign the value as states. But since now we are plotting the bar graph horizontally, we will have murders for the x label instead of states. We will use ylab parameter to assign the values for the y-axis, and we will assign states. We can also assign the title for the graph using the main parameter, that is main, and let us assign the value as states versus murders. We can also assign the colors for the bars, so we will use COL parameter and assign the value as blue. When we execute the statement, you can find that the bar graph has been plotted horizontally with the labels for x-axis as murders and y-axis as states. We can also have the values for the y-axis using the names.arg parameter, and let us assign the value as mySELData followed by $sign and states. When we execute the statement, you can find that Values for the y-axis, that is states, are also assigned. So this is how bar graph can also be plotted horizontally. In this video, we will look at how to plot stacked bar plots. Let us begin by loading the dplyr package. We will use the library function and within parentheses we will pass dplyr. In the next statement, we will create an object myData, and with the assignment operator and read.csv function, we will import the data from murdersmini.csv file. This CSV file contains data of states, population, and murders. We will create an object myCellData, and using the assignment operator and mutate function, we will pass the first argument as myData. The second argument, we will mutate the dataset with POPU column, that is, we are dividing the population by 10,000. In the next statement, we will use the names function to display the column names of the data frame, that is mySCLData. When we execute these statements, you can find that the data frame mySCLData now contains 4 columns. The first 3 columns are from the dataset, that is murdersmini.csv file, and the fourth column POPU is the mutated column, that is the population divided by 10,000. We have created this column just for the sake of the convenience for plotting the bar graph. In the next statement, we will use mySCLData, and with the assignment operator, we will select only the first, third, and fourth column. So we will have mySCLData. Within square brackets, we will use the C function and we will select the first, third, and the fourth column. In the next statement, we will use the bar plot function to plot the bar graph. The first argument we will pass is mySCLData, followed by the dollar symbol and then the column name, that is POPU, which is a mutated column. When we execute these statements, you can find that bar graph has been plotted for population's data. Let us plot the bar graph for murders data. When we execute this statement, you can find that the bar graph has been plotted for murders data. If you observe, these two graphs has been plotted separately. But suppose we need to compare the population and the murders with respect to states, we have to create a stacked bar plot. The bar plot function takes in the first argument as the vector or a matrix. When we use the first argument for the bar plot function as a vector, the function will create a simple bar graph. But when the first argument of the bar plot function is passed as a matrix, then the bar plot function will create stacked bar plots. So we will create a matrix which contains states, murders, and populations as the columns. Let us create an object myMatrix, and using the assignment operator and data.matrix function, we will convert the data frame, that is mySCLData, into a matrix. So we will pass the argument as mySCLData for the matrix function. Let us display the contents of myMatrix. When we execute the statement, you can find that we have the 3 columns for the matrix, that is state, murders, and POPU. And if you observe, the states column does not contain names of the states, but it contains a numeric value. Since matrices can have only numeric elements, we will create an object myMatrixTrans, and using the assignment operator with the T function, which stands for transpose, we will pass the matrix, that is myMatrix in this case. We will print the contents of myMatrixTrans object. When you execute these statements, you can find that we have performed the transpose operation, and now the object myMatrixTrans contains only 3 rows, that is state, murders, and POPU. Now this transposed matrix can be used to create stacked bar plots, where the first row, that is states, will be considered as the bars on the x-axis, and the other rows, that is murders and POPU, will be used to plot the bars. Let us now use the bar plot function, and we will pass the matrix, that is myMatrixTrans. When we execute the statement, you can find that we have the stacked bar plot, and the POPU and murders bars are stacked on one another. We can change the look and feel for the stacked bar plots. Let us use the parameter as xlab and assign the value as states. We will give the title using the main parameter. That is, we will have the title as population versus murders. We can assign the colors to the bars using the COL parameter. In this case, we will use a vector of colors. That is, using the C function, we will have the first element as blue color and the second element as red color, since we have multiple bars to be stacked. When we execute the statement, you can find that we have the stacked bar plot. We can also assign the values for the x-axis using the names.arg parameter. That is, in this case, we will assign mySEL data followed by the dollar symbol and state, which is the column name. When we execute this statement, you can find that we have assigned the values to the x-axis as states. We can also have legend, which defines the representation of colors for various bars. So we will use legend as the function, and the first argument we will provide as the position, that is, let us say top left within single quotes. The second argument we will have as a vector, and using the C function we will have the first element as population and the second element as murders. And the third parameter for the legend function would be the fill parameter. So we will use fill and assign the vector, that is, using the C function, we will assign the first value as blue color and the second value as red color. When we execute this statement, you can find that on the stacked bar plot, we also have the legend, which describes or represents the colors used by the data. So this is how stacked bar plots can be created in R programming language. In this video, we will look at how to plot histograms. Histogram is another graphical representation of data where range is divided into intervals or bins, and consecutive bars are drawn with their height proportional to the count of the value in each bin or the frequency of the values in the bins. We will look at how to create histograms in R programming language. To demonstrate histograms, we will use the stock price data. Let us begin by loading the dplyr library package using the library function. In the next statement, we will create an object myData, and with the assignment operator and read.csv function, we will import the data from gestock.csv file. The gestock.csv file contains date and price of the stock on that date. Now let us create an object mySubData. We will use the assignment operator with the select function, and the first argument of the select function will be the data frame. That is, in this case, it is myData. The other arguments are the columns which we want to select. For example, we will use date and price. To create histograms, we need to use hist function. The argument for the hist function is the numerical vector. So let us use mySubData, and with the dollar symbol, we will pass the price column, which contains the value of the stock price. Let us execute these statements. The first statement will load the dplyr library. The second statement will read the data from gestocks.csv file. The third statement uses the select function from the dplyr library, where we are selecting two columns, that is date and price. The subsequent statement will plot the histogram. When we execute the statement, you can find that histogram is plotted. We can click the zoom button to view the zoomed histogram. We can use the other parameters of the hist function to change the look and feel of the histogram. Let us provide the label for the x-axis using the xlab parameter and assign the value as stock price as a string. We can also provide the title for the histogram using the main parameter and assign the value as, let's say, stocks data within single quotes. We can also change the color of the histogram using the COL parameter, and let us assign the value as blue within quotes. As well as we can use the border parameter and let us assign the value as red within single quotes. Now when we execute the hist function, you can find that we have the title of the histogram, that is stocks data. We also have the label for the x-axis, that is stock price, and the histograms are plotted in blue color with red border. By default, the hist function will divide the range into 10 bins. We can change the number of bins using the breaks parameter of the hist function. For example, let us use breaks parameter and assign the value as 20. That is, for this histogram, we are dividing the range of the data into 20 bins. Let us execute the statement. You can find that the histogram is now using 20 bins to represent the data. So this is how we can use hist function to plot histograms. Let us now look at how to generate scattered plots. We will use the same murders data and we will create an object mySubData. And using the assignment operator and select function, the first argument of the select function we will pass myData, which is a data frame. We will select the columns as state, population, and murders. In our programming language, we can use plot function to generate scattered plots. The plot function is a generic function for plotting our objects. So let us use plot function and let us consider that we will be plotting population against murders. So we need to pass a numeric vector for x-axis values. In this case, we will use mySubData with the $symbol and pass the population vector. The second argument would be numeric vector for values of the y-axis. In this case, we have mySubData with the $symbol and murders vector. Let us execute these statements. You can find that the plot function has plotted the basic scattered plot. The plot function also provides certain parameters through which we can change the look and feel of the graph. So let us use the parameter xlab and assign the label as population since we have population data on x-axis. We will use the ylab parameter and assign the label as murders. We will use the main parameter and assign the label for the title. That is, let us say population versus murders. We will change the color for the plotted values. That is, we will use COL parameter and let us assign the value as red. Let us again execute the statement. You can find the title for the scattered plot as well as the labels for x and y axis. That is, population and murders. We can also change the shape of the points for the scattered plot using the PCH parameter. So let us use PCH parameter and assign the value as, let's say, 20. Let us execute the statement once again. And you can now find that the shape of the points for the scattered graph is changed. Our programming language has certain predefined values for the PCH parameter. For example, if we use the value as 10 and execute the statement, you can find that you will have the different shapes for the points. If you look at the scattered plot, you can observe that there is a strong relationship between population and murders. That is, the higher the population, the higher are the murders. We can also use plot function to generate line graphs. For example, we will use plot function and then pass the argument as vector. In this case, we will pass the murders vector. So we will use mySubData followed by $symbol and then murders column. To generate line plots using the plot function, we need to use the parameter as type and assign the value as L. Let us execute these statements. You can find that the basic line plot has been generated. We can use the other parameters to change the look and feel of the line plot. We will use the parameter xlab and assign the value as states. For y-axis label, we will use ylab and assign the value as, let's say, murders. We will use the main parameter to assign the title of the line plot. That is, in this case, we will say states versus murders. We can also change the color of the line using the COL parameter. We will assign the color as blue. Let us execute the statement. You can find that the title as well as x and y axis has been labeled with the line color changed to blue. So this is how line graphs or line plots can be created using the plot function. We can also generate box plots which can be created for grouped values. The box plot produces the brief summary of the data. Let us create an object as mySubData. Using the assignment operator and the select function, we will pass the first argument for the select function as myData, which is a data frame, and we will select the columns as state, population, murders, as well as region. We will also select the region column since we will be grouping the number of murders according to the region. Now we will use the box plot function. The first argument of the box plot function would be a formula. That is, let us use mySubData with the $symbol. We will select murders vector. and the tilde symbol, we will have my subdata followed by the dollar symbol and region. Here in the formula, my subdata $murders is a numeric vector of data values to be split into groups according to the grouping variable, that is, in this case it is regions. So we will be grouping number of murders according to regions and plotting this data through the box plot function. Let us execute these statements. You can find that we have the box plot generated. We can use other parameters to change the look and feel of the box plot. For example, we can use xlab to assign the x-axis label. That is, in this case we will say region. Then we can also use ylab and assign the value as murders, which is the label for the y-axis. Let us give the title for the box plot using the main parameter. Let us say regions versus murders. We can use the color for the boxes using the COL parameter, that is, in this case we will provide it as red. We can also use the border parameter and let us provide the color as blue. We will execute the statement. You can find that box plot is displayed according to the values assigned to the parameters. We also have a parameter as notch. This parameter takes a logical value. By default it is false. So let us provide true and execute the statement. You can find that the notch is drawn on each side of the box. If we find notches overlapping each other, then we say that there is a strong evidence that the two medians differ. In this case, we also have a warning that the notches are outside the boxes. This is because of the murder values which we have grouped according to regions. So this is how we can use the box plot function to generate box plots. In this video, we will look at how to create and generate multiple plots or combination of plots. To demonstrate the generation of plots, we will use the murders dataset. Let us begin by loading the dplyr package. We will use the library function and within parentheses, we will pass dplyr. In the next statement, we will create an object myData, and with the assignment operator and read.csv function, we will import the data from the murdersmini.csv file. The murdersmini.csv file contains the data of states, population and murders. So we will pass the dataset as murdersmini.csv. In the next statement, we will create an object mySELData, and using the assignment operator and mutate function, the first argument for the mutate function, we will pass myData, which is a data frame. And the second argument would be the mutated column, that is, in this case, popu. So we will have popu equal to population divided by 10,000. We are creating this popu as a mutated column just for the sake of convenience of displaying the values for the plots. In the next statement, we will select first, third and fourth column from mySELData, which is a data frame. So we will have the object as mySELData followed by the assignment operator, and again we will use mySELData, and within square brackets we will use the C function to select the first, third and the fourth column. For our convenience, we will use the names function and we will pass the argument as mySELData to have the better understanding of which columns we are selecting. Let us execute these statements. You can find that the names function has returned state, population and murders as the column along with the mutated column, that is popu. In the subsequent statement, we have used a C function where we use the first element as 1, which represents the states column, and then we are using the third column. So we are not selecting populations but we are selecting murders, and finally we are selecting the fourth column, that is popu. Let us use a bar plot function to create a bar graph. The first argument we will pass is mySELData followed by the $sign and popu as the column. The second argument we will use is xlab and assign the value as states. And the third argument we will use is ylab and assign the value as population. We will also provide the title using the main parameter and assign the value as state versus population. We will provide color for the bars using the COL parameter and assign the value as blue. And finally, we will use names.arg parameter and assign the values as mySELData followed by the $symbol and state as the column. We will create another bar graph using the bar plot function. The first argument we will pass is MySCL data followed by $ and murders column. The second argument will be xlab and we will assign the value as states. The third parameter will be ylab and we will assign the value as murders. We will also provide the title for the bar plot using the main parameter and assign the value as state versus murders. We will use COL parameter to assign the color. In this case, we will assign blue. And finally, we will use names.arg parameter and assign the value as MySCL data followed by $ and state, which is a column. Let us execute these statements. You can find that bar plot for state versus population has been plotted. The subsequent statement will plot the bar graph for state versus murders. But if you observe here, two different graphs have been created. We will now try to generate multiple plots on the same display. To do this, we need to use par function, which is used to set or query the graphical parameters. So the very first line of our program, we will use the par function and we will make use of mfRow parameter through which subsequent figures or plots can be drawn in a row and column array. The mfRow parameter takes in vector as the values. So we will use C function to create a vector which has elements 1, 2. The first element represents a row and the second element represents the columns. So what this means is that we are dividing the layout into one row with two columns. Let us execute these statements from the beginning. You can find that two bar plots have been displayed within the plot's layout. On the left side, you find the bar plot with state versus population, and on the right side, you will find the bar plot for state versus murders. Let us create a third plot. For example, we will create a scattered plot using the plot function. The first argument we will pass is MySCL data followed by the $ and popu as the column. The second argument we will pass is MySCL data followed by the $ and murders as the column. We will use the other parameters, that is xlab, we will assign the value as population, and for the ylab, we will assign the value as murders. We will also have the title for the scattered plot, that is we will use main parameter and assign the value as population versus murders. We will use the COL parameter to assign the red color to the scattered points. And finally, we will use the PCH parameter and assign the value as 20. PCH stands for plotting character, which has predefined values. Let us execute the statement. You can find that the scattered plot has been plotted in the first row first column of the plot's layout. But suppose if we need all the three graphs to be plotted in the same layout, we can change the vector for the mfRow attribute in the par function. So let us have the vector as 2, 2, which means that now we are dividing the layout into 2 rows and 2 columns. Let us execute these statements from the beginning. You can find that the bar plot for state versus population is plotted in the first row and first column. The bar plot for state versus murders is plotted in the first row and second column. And subsequently, the scattered plot for population versus murders is plotted in the second row and first column. So this is how, using the par function provided in the R programming language, we can display multiple plots within the plot's layout.